So welcome to the track 4E, personality traits and choice models. Sorry about that, I think you can see it better now. And I'm your moderator, Giancarlos Parady from the University of Tokyo. And today we have 4 presentations. So I want to just take a quick attendance. So Mr. Yu Gu. Can you hear me?
Yeah.
Yeah.
Okay.
So, no, give me 1 second. Just Mr. Yu Wang.
Yu Wang, he wants you to indicate that you're here and with us.
Yeah. I'm here.
Okay.
Thank you.
Sorry. And then Mr. Ali, I just saw your screen earlier. So, okay. So we have 4 presentations. So let me just briefly introduce our speakers. So our first reminder about the details, right? So each presenter is allowed 15 minutes per presentation and 5 minutes for Q&A. So because we only have 4 presentations, we have a little bit of time, but I would prefer we stick up to the 15 minutes and then allow for more time for discussion. Yes, Kara.
I'm so sorry, but I think it's much easier for them to present longer than for you guys to come up with 15 minutes of Q&A or 13 minutes or whatever it turns out to be. So yeah, I would let them go for at least 20. BTR in the past was always a 30-minute time slot, and with most of it consumed by the presentation. So okay. I'd let them go if they have that many slides.
Okay, I think one of them does, but I just judging from yesterday's experience, just in case I wanted to have the time. But yes, okay. So if you have, we'll be lenient in that sense. If you have 20 minutes, I will not cut you off at 15. So let's do that. But I will still post reminders on the chat 3 minutes and 1 minute before the 15 minutes time run out, and then you have an extra 5 minutes if you need them. And then please ask your questions via chat, and then I will keep track of them, similar to what we just did in the headliner session, and then I will ask them directly to the presenter to avoid wasting time and switching cameras on and off. And so yes, let's go introduce our speaker. So our first speaker is Mr. Yu Gu. He's a PhD candidate in civil and environmental engineering from Hong Kong Polytechnical University. And his research interests include transportation network modeling, path flow estimate, and transportation reliability, as well as vulnerability and resilience. And he's going to be talking about a Weibit choice model, properties and mode choice application, and graphical illustrations. Our second presenter is Mr. Yu Wang. He's a PhD candidate at ITS at Leeds and also at the Beijing Yacan University. And he's going to be talking about hybrid multiple discrete continuous models to capture risk perception and travel mode choice during the COVID-19 pandemic. And our last 2 presentations will be by Mr. Ali Khanpour. So the first one is validation of the inventory of driving-related personality traits, IVPE. And the second one will be about evaluating the impact of driver sensitivity to reward and punishment, personality dispositions, and socio-demographic characteristics and individuals' accident proneness, a structural equations model. And Mr. Khanpour holds a master's degree in transportation planning engineering from the Imam Khomeini International University in Iran. And he has also work experience in as transportation planning manager and as a consultant from the Transportation Deputy Minister, and has also been involved in more than 16 research projects related to transportation. So without further ado, I would like to give the floor to our first presenter, Mr. Yu Gu, on Weibit choice models. So whenever you're ready.
Yeah, thank you.
Your screen.
Okay. Thank you, everyone. And today my presentation is to introduce a newly developed travel choice model called Weibit model. And in this presentation, I'm going to use some graphical illustrations to further show the properties and some applications of the Weibit model. This is the outline of my presentation. And then first I will show the background and motivation of the developing and applying the Weibit choice model. It's known that in the transportation literature, the travel choice, there will be perception error in the travel choice. And the perceived travel cost is often represented as the summation of a system utility, Vi, and the random error term, epsilon I. By assuming different distribution of epsilon I, we can get different travel choice models. And in literature, the two major streams of travel choice models are first, the logic choice model based on the Gumbel distributed random error term. And then is by assuming normally distributed random error term, we can have the multinomial probit model. And at the, at the bottom of my slide, I show the choice probability expression of the two models. We can see that there is a closed form choice probability for the logic model. However, the multinomial probit does not have a closed form, which means it is expressed in integrals. And I briefly summarize the pros and cons of two types of models. It's known that probit models are more flexible and may give us more realistic results. However, the lack of closed form probability will largely increase its computational burden, and especially when we want to consider the network equilibrium problems. In network equilibrium, we want to consider the congestion effect on people's different travel choices. And however, this requires us to iteratively solve for the large number of new choice probabilities, especially when we apply them in the large scale network. Therefore, the logic model is more commonly adopted in the equilibrium models. However, the logic model has its own limitations. For example, it's enabled to consider similarity or heterogeneity of travel alternatives. And this is due to the IID assumption. There are many ways to relax the assumption and to solve the similarity and heterogeneity issues. However, these approaches either cannot handle the two assumptions in the same time, or it does not give us a closed form probability expression. A few approaches can remain the closed form expression while relax the IID assumption. However, there are still obstacles for them to apply in equilibrium models. Therefore, one may ask whether we have a third alternative of the Weibit model of the travel choice model that can address some issues in the logic model while remaining a closed form expression. And in 2008, Castillo et al. Proposed the third alternative called Weibit model. Here we compare the multinomial Weibit model with the multinomial logic model. It can be seen that the difference is that the Weibit model assumed the Weibel distributed random error term, and also it assumed a multiplicative disutility function. Here, the way for Weibit represents the disutility, while the way for logic represents the utility. And the random error term is multiplied with the system utility. Because of these two differences, the Weibit model can inherently relax the identically distributed assumption by allowing an alternative specific perception variance. And note that the logic model often assumes a fixed variance. And I will discuss it later. And why this relaxation is important. Let's say the illustrative example in a short network and a long network. Consider the choice that will be made between two modes. The short network in both networks, the difference in the mode disutility remains the same, which is 5. However, in this case, if you use the logic model with the same dispersion parameter, you can see that the same choice probability is given for different networks. And this result seems unrealistic because in the longer network, the difference in mode disutility becomes less significant. And the choice probability of mode 1 should be lower. And this can be addressed by the Weibit model because we can find different choice probabilities for different networks. And in the longer network, the choice probability of the mode 1 approaches 0.5. And this is in accordance with our intuition. Therefore, we can see that in some cases, the Weibit model might outperform the logic model. However, the literature on Weibit model is still far from exhausted. And this maybe is because the understanding of the properties and some other features of the Weibit model are not well clarified. Therefore, this study wants to take one step back to first illustrate the properties of the Weibit distribution embedded in the Weibit model, and then, based on this, we will graphically illustrate the derivations and some properties. First, I will introduce the Weibit distribution and compare it with the Gumbel one. We can see that the Gumbel distribution has two parameters, the location parameter and the scale parameter. And the scale parameter is used as a dispersion parameter in the choice. And for Weibit distribution, the location parameter, it has location parameter, scale parameter, and shape parameter. And this is the general form of Weibit distribution. And so this figure gives us a PDF function, the curves of PDF function of Gumbel distribution and three Weibit distributions. And this figure gives the CDF curve. We can see that although the CDF curves are similar to each other, the two distributions may have totally different properties. This slide shows us the statistical properties of the two distributions. We can see that from property 3, that the Gumbel distribution gives us a fixed variance if we have a given theta, a given scale parameter. But the variance of Weibit distribution is dependent on alpha, and alpha is associated with the mean, which means the Weibit distribution gives us an alternative specific perception variance, which is proportional to its mean. And property 5 is associated with the derivation of binary choice model. For the Gumbel distribution, the difference between two Gumbel distributive variables with the same scale parameter follows the logistic distribution, and it's known that the probability of choosing one alternative is a probability that its utility is larger, which means which gives the binary logic choice probability here, which is based on the absolute difference between utilities. In an analogous way, we can derive the Weibit choice probability based on the property that the ratio of two independently Weibit distributive variables with the same shape parameter beta follows the log logistic distribution. And in this case, the probability of choosing one alternative is the probability that the disutility of it is lower, which means the derived Weibit choice probability is based on the relative difference or the ratio between the disutilities. And the last property is about the max or mean stable property. The Gumbel distribution is known to be max stable, which means that the maximum of independently Gumbel distributive variables with the same scale parameter is still Gumbel distributed, but with a different location parameter. Here is the form of the location parameter, which is associated with the expectation of the maximum perceived utility we can gain from the choice set. And this is also associated with the well-known log sum error that can be used for network accessibility or vulnerability analysis, and we will discuss it later. And similarly, the Weibit distribution has a mean stable property, which means that the minimum of independently Weibit distributive variables with the same shape parameter is still Weibit distributed, but with a different scale parameter. And the form of scale parameter, similar to in analogous to the Gumbel distribution, is associated with the expectation of the minimum perceived disutility from a choice set, and also can be used for accessibility or vulnerability analysis. And here we want to first illustrate the derivation of the multinomial choice model based on property 6 together with property 5. And here we consider using a graph to illustrate the derivation. First, look at the logic case. It's known as the multinomial choice probability of A1 among 3 alternatives, and A1 is described in a blue curve. And this probability is equivalent to the probability that the utility of A1 is larger than the maximum of A2 and A3. And because of property 6, A2 and A3 with the same scale parameter its maximum is still Gumbel distributed. And then the multinomial choice problem becomes the binary problem. And then using property 5, we can derive the difference between A1 and A star, and we can get the logic probability as shown in the shaded area. And in a similar way, we can get the multinomial Weibit. The multinomial Weibit choice probability of choosing A1 is the probability that A1 has a minimum disutility, which means the disutility of A1 is lower than the minimum of A2 and A3. And using property 6, the minimum of A2 and A3 is still Weibel distributed with the same shape parameter. And it allows us to use property 5 to get the binary Weibit choice probability, which gives us the multinomial Weibit probability of choosing A1. And this is showing the shaded area. And given the different derivation of the two models, let's revisit the mode choice example we discussed in the motivation part. And let's say why the two choice models give us two different probabilities. First, we look at the logic model. We can say that by assuming Gumbel distributions for mode disutility, the curves of the disutility remain the same for even different network. And the only difference is that the location is moved in parallel. However, this cannot affect the difference between the two Gumbel variables. Therefore, we get the same logic, binary logic choice probability in both networks. However, if we assume Weibel distributions, we can see that the curves change a lot. And then by taking the ratio, we can get totally different Weibel over Weibit choice probability. And besides the choice probability, the two model gives us different performances in network evaluation. Here we consider the accessibility and vulnerability analysis. The accessibility is simply represented by the utility-based measure. For the logic-based case, it is the well-known log sum as shown here. And for the Weibit case, it is in this form. And often we want to consider the vulnerability of a network due to some disruptive events. For example, we want to measure the degradation in network performance under, for example, natural disasters or human-made attacks. And then for the logic case, it's natural to derive the absolute difference between pre-disruption accessibility and post-disruption accessibility and use it as a network vulnerability measure. Also, if we want to compare the vulnerability among different networks or different regions, we want to know the relative reduction in accessibility, and then we need to use the equation at the bottom. And this is more commonly adopted. However, if we want to use the Weibit-based accessibility for vulnerability, it's more direct to directly use the ratio. To directly use the ratio between pre and post-disruption Weibit accessibility measures. And this is because Weibit-based choice probability is directly based on the relative difference in disutility. And why these two measures are different in the vulnerability analysis, let's still look at an illustrative example. We consider the choice between one OD pair with two alternatives and their disutility represented as V1 and V2. And if we want to consider the vulnerability when there is a 20% increase in disutility of both alternatives under the disruption, then we can easily find that the Weibit vulnerability measure can give us an accurate outcome, which gives us a 20% increase in disutility. However, if we use the log sum measure, it will give some best result. For example, at the bottom, I show the difference between the actually derived log sum measure and the expected log sum measure that gives a 20% decrease in utility. The horizontal axis is the difference between V1 and V2. We can see that the actually derived log sum is always lower than the expected one, which means it overestimates vulnerability in this case. And the overestimation becomes larger when the difference between alternative 1 and alternative 2 are smaller. And this suggests that the Weibit-based accessibility measure can be more suitable for deriving the relative decrease in or relative degradation in network performance. And finally, the conclusions. Here, I just provide several possible directions for future studies based on Weibit models. First, we can develop more advanced Weibit models, and recalling that the multinomial Weibit model only relax the independently distributed assumption, and we can relax the RID assumption at the same time. Also, there are many applications of Weibit model, for example, the accessibility and vulnerability analysis, and also we can apply them to other choice dimensions or integrate the Weibit models into decision-making, like network design. And that's all for my presentation. Thank you for listening.
Hi, Frank. So you mentioned, in our communications by email, I asked you to do a 15-minute presentation, but if you have the additional slides regarding the nested extension, you can present that as well.
Oh, thank you.
So he has some additional slides that, because I asked him, he asked me if he could do a 20-minute presentation earlier, and I said 15, but he has some additional extensions about the nested Weibit. So that will be interesting to complement your presentation.
Yeah, thank you. I will first go to this slide. This further shows some, oh, sorry. I don't know why this, okay. I don't know why this automatically go first. So I use this version. And in this slide, I further show some properties of the Weibit-based accessibility measure when it is applied to the vulnerability analysis. Besides just assess the network vulnerability in terms of degradation in network performance, we also want to know the important links in a network, which means an important link is that if we remove or degrade this link from the network, there will be a large degradation in network performance for the whole network. And here, if we want to use the log sum-based measure for the smaller and larger network, the absolute difference between after removing alternative 1 and alternative 2 remains the same ratio, which gives us the same relative importance between A1 and A2. Anyway, this is unrealistic because, as we discussed in the longer network, the two alternatives seems much more similar to each other. And for the Weibit, if we use the Weibit-based availability measure for deriving the importance, after successively remove alternative 1 and alternative 2, we can get the different relative importance, and which is more consistent with our intuition. Also, I show some possible extensions of the Weibit model, because the multinomial Weibit model only focus on relaxing the identically distributed assumption. And if we want to relax the independently distributed assumption, we can use some existing tactics from the extended closed form logic models. For example, we can use the choice structure of the nested logic model to get the nested Weibit model. And by connecting the modes or alternatives with some similarity in the same nest, we can derive the nested Weibit model, and the nested Weibit choice probability is shown here. In this model, we use parameter phi to represent the ratio between beta and beta u, which are the shape parameter at different choice levels. And then this shows the degree of similarity between different modes or different alternatives in the same length. A higher value of phi refers to a lower level of mode similarity, and if phi equals 1, the nested Weibit degenerates to the multinomial Weibit. And finally, is a cross-nested Weibit model. This is a more flexible choice structure, which allows the overlap among nests. For example, we can say that the mode EB can belong to the can simultaneously belong to different nets. And then in this choice probability expression, we include the membership parameter mu to denote the contribution of one mode or one alternative to the best. And that's all for the extensions. Thank you.
Okay, thank you very much. I think that was a very enlightening and educational presentation. You did a very good job connecting the intuition to the mathematics. So are there any questions regarding this presentation? Okay, so let me just start then. So I have a question regarding, so you mentioned the theoretical advantages of using the Weibit against the multinomial logic, in this particular case with the network. So have you done comparisons in terms of predictability? So we want to see if the theoretical intuition is actually translates into better model performance. So have you done some tests like cross-validation of different models and see which one performs better?
Thank you for the question. Actually, we did not do any econometric studies based on the Weibit model because we mainly use the Weibit model in the network equilibrium problem. This is because the closed form of the Weibit model and the characteristics shown here, because we just consider the shape parameter or the scale parameter is calibrated, and then we use the calibrated model to in the equilibrium model to model the congestion effect in the choice. For example, we consider the congestion in root choice in most cases, and now we want to extend it to consider congestion in mode or destination choice in future study. However, we do not have experience in some econometric studies.
Okay, it will be interesting to see because we like to connect the theory with the result in practice as well.
Yeah.
Actually, my follow-up question was actually related to the same thing. You're focusing on network now, but I was wondering, like, when you think about mode choice or other choice dimensions, do you think there are any particular applications where the Weibit assumptions are actually superior or more appropriate to the modeling problem than the logic assumptions?
Yeah, thank you. And I think the major difference is actually comes from the multiplicative distributive function. And in an earlier work, some two authors from the North Europe shown that the multiplicative distributive function might outperform the additive utility function in some empirical cases. And I think this may be because that the Weibit model, because Weibit distribution allows alternative specific perception variance, and then we can say that there is a power function based Weibit choice probability expression, which means that in the Weibit model the variance is proportional to the mean, but not a fixed one. And in such cases, the Weibit model will, I guess, will outperform the logic one.
Yeah,
and
so I'm curious about which cases are we talking about?
Thank you. For example, if I use example in root choice, because if we consider a network with different scale, different trip lengths, then the power-based function might give us a more realistic result when there are both long and short routes, which means different magnitudes of trip lengths in one network. And in this case, will outperform the logic one. And also in destination choice, actually the power function and exponential power function has been used in the trip distribution models. And some studies show that the power function might outperform the exponential function when the trip lengths are longer. And this might be the application in destination choice, and we will discuss it and we will investigate this topic in our future studies.
Okay, thank you very much. I think I want to use these slides in class when I talk about logic models.
Thank you.
Any other questions regarding this presentation? Okay, if there are no questions, I would like to wrap it up here, but if you feel free to ask in the chat, and I think Frank will be glad to do them.
Sure.
So thank you very much.
Thank you. See you.
Okay, so I would like to move on to our second presenter of the day, which is, let me go back to my slides, Mr. Wang, I think. Yes, so Mr. Wang talking about a hybrid multiple discrete continuous model to capture risk perception and travel mode choice during the COVID-19 pandemic. So whenever you're ready.
Hi, good morning and good afternoon, everyone. Could you please see, can you see my screen now?
Yes, we can see it.
Okay, thank you very much. Okay, I will start my presentation. First, I would like to show my great honor to have the opportunity to present here. The topic of my presentation is a hybrid multiple discrete continuous model to capture risk perceptions and the travel mode choice during the COVID-19 pandemic. This paper is co-authored with Professor Chris Ma, Professor Thomas Hancock from ITS, and Professor Yacan from Beijing Jiaotong University, and Professor Juan. First, let me introduce the background. The COVID-19 pandemic has had a significant impact on people's lives around the world, and this includes an overall reduction in daily travel and out-of-home activities. And the studies in psychology have highlighted the important role of risk perception and risk communication during a hazard to ensure an appropriate response. However, understanding the public's perception of risk events during the pandemic is less studied and is essential for designing an appropriate risk communication strategies in the field of transportation. So this drives our research questions. This paper put a special focus on modeling the changing mode choice and travel frequencies over time and formulating risk communication strategies for travelers. With three special focus research questions. The first is how is risk perception is influenced by information? And what are travelers' perception of different travel risk events during the pandemic, and how to design risk communication strategies based on travelers' travel risk perceptions. First, this is the data collection process. Our data is collected during the third waves of pandemic in Beijing. The target population was Beijing residents, and the screening questions were used to filter out respondents who didn't live in this area throughout the third waves of pandemic. And finally, 424 valid questionnaires were collected. First, let me introduce the risk map, the risk perception map. Slovak proposed the map of risk perception for understanding public perceptions of hazards visually. Based on how people scored these two factors of different risk events, risk perception can be visually displayed on the map of risk perception. The first is labeled as lack of control. It's defined as its high end by perceived lack of control, dried, or very risk potential risk events. And the second factor labeled unfamiliar, as it's defined as the high end by hazards judged to be unobservable, unknown, new, delayed in their science field, something like that. We designed the risk events in our research through three steps. First, the candidate risk events were selected from news and social media. Then the candidate events were screened through focus group interviews, and only the most important were retained. And third, expert interviews were also conducted to help us decide which events were worth studying. And finally, we got 17 risk events from 3 categories. First is the risk events about the virus itself. And the second category is risk events about using public transport during COVID-19. And the third category is risk events using some taxis and online car hailing during the COVID-19. This is our key variable, the travel mode choice and travel frequency changes during and before the pandemic. Different categories of trip frequencies were collected. Therefore, we collect the travel mode and frequency choice both before the pandemic and during the pandemic. So the independent variables are multiple discrete continuous variables with 2 components. First, the discrete mode choice, and then the continuous mode specific weekly trip frequency. And this is the comparison of frequency change before and during the pandemic, and we can see travelers reduce the use of bus and subway travels and increase the use of car, bike, shared bike, walk, and other kinds of travel mode. We use a typical MDCV model structure, except that we combine it with a mimic model and use shift parameters to check whether parameters estimates are significantly different before and during the COVID. This is the mimic model structure. The measurement model is about how the latent variable is identified, and the structural equations represents the effect of observable variables on the latent variables. And this is the model framework of the MDCV model. We use the gamma profile model, and the gamma parameter is a situation parameter, determines the situation effect of the travel frequency for each mode. A lower satiation parameter suggests that the travelers get satiated more easily with the use of that travel mode and are less willing to use it. About the latent variable, there are 3 potential latent variables. First, the first 2 is about travelers' attitudes towards different kinds of information, towards positive information and negative information. The third latent variable is about travelers' risk perception. And these are the list of explanatory variables, including social demographics and other variables related to COVID-19. For example, if there are family members who are vulnerable to infection, or someone in the family are object travelers to use public transport, something like that. Here is the result. First, I would like to show the result of the map of risk perceptions. Different kinds of risk events were located in different areas of the map. On the map, the average values for the unfamiliar and uncontrolled are about 3 respectively. This study used the average value of the 2 factors as the origin of the coordinate system to draw the map of risk perception. As shown on the map, the risk events related to the virus, variation, potential sequela, long-term existence with a human are perceived as the most unfamiliar and uncontrollable by the participants. And infectivity of COVID-19, urban preventive measures, and fake news and fake preventive measures are in the third quadrant, which means respondents know these risk events well and they think they are controllable. About the risk events about travel itself, most of them are located in the fourth quadrant, which means people are people think are unfamiliar and but think they are controllable. About the results of the hybrid choice model, first, the ASC of public transport are higher than the reference. Sorry, we use the active mode as reference in our model before the COVID, and yeah, the ASC of public transport are higher than the reference before COVID-19, but all of the ASC of other modes are lower. However, the COVID-19's negative effects on public transport, which were reported in other studies, are also reflected in this model. The ASC of public transport decreased the most during the COVID-19, while the ASC of car and shared bags increased, which means car and shared bags is much popular during in the COVID-19. About the situation parameter gamma, before COVID-19, public transport has the highest situation parameter, followed by active modes, car, shared bike, taxi, and the other mode. During the COVID-19, the order of the situation parameter for all modes were nearly the same, except for the case of public transport and active modes. Public transport shows a strong decrease in situation parameter, which car and shared bags values increase the most. About the estimation results of the choice part, there is a significant declining propensity for choosing public transport during male respondents during COVID-19, while the use of car and shared bags increased. For younger travelers prefer public transport and shared bags both before and during COVID-19. And for low-income groups, they are more likely to choose public transport, perhaps as a result of being unable to change the travel mode during the COVID-19. As would be expected, individuals who own more cars and those who live in areas with COVID-19 cases decrease the use of public transport significantly. In addition, compared with travelers with higher education levels, median level travelers are less willing to use public transport during COVID-19. And about the other variables, if there are individuals in the family that are vulnerable to infection, such as the elderly and the young children, respondents prefer not to use public transport during COVID-19. And this also occurs if there are family members who object to use of public transport. And the results shows that if respondents had been vaccinated against COVID-19, the use of public transport and shared bags increased significantly, and the use of car decreases. Finally, in terms of the risk perception, the latent variable, people with higher risk perception of public transport are less likely to use the public transport, but more likely to use shared bikes and cars during the pandemic. About the results of the mimic structural model, travelers show significant heterogeneity in the results. The latent variable attitudes towards positive information is explained by gender, age, number of cars, and vaccine. For example, travelers with higher concern about positive information are more likely to be women, those aged 30 to 50, and individuals who have not yet been vaccinated. Meanwhile, the latent variable attitudes towards negative information explained by age, income, number of cars, and the health status of family members. If from a pandemic area and whether have been vaccinated. For example, if a person in the family are vulnerable to infection, the traveler pays more attention to negative information. And if people get vaccinated, they will pay less attention to both types of information. Finally, the latent variable risk perception is affected by the other two latent variables. More attention to positive information reduces the risk perception, while negative information has the opposite effect. This result is consistent with the findings of Slovics. And the risk perception is also influenced by gender, educational level, and health status of the family. This give us some policy implications that for different people we should design different kinds of risk communication strategies. For example, for males, they are more sensitive to positive information. We then should think about the preventive measures of the city and different kinds of positive information for them to help them construct the correct risk perception during pandemics. And this is the conclusion and the discussion. First, the effect of information on travelers' risk perception. Information that is closely related to travelers' daily life can affect their risk perception most. And about travelers' behavior change during the COVID-19, travelers are reluctant to use subways and buses during the pandemic and are more inclined to use more personalized modes, especially private cars. At the same time, our data also suggests that shared bicycles are very popular during the pandemic. The influence of COVID-19 are significantly different among travelers. And about the targeted risk communication strategies, we can consider heterogeneous communication strategies for different kinds of travelers. Thanks for listening. Comments, please. Thank you very much.
Thank you very much for your presentation. Is it possible for you to turn your video on? Mr. Wang?
Hello.
Can you turn your video on? Is it possible?
Oh, sorry, my internet is not very good, so maybe
okay.
not. Yeah.
Then no problem. Okay, so I have one comment and a few questions. So the first, it's a comment mostly. So you talk about the policy implications and you describe the model, right? But you mostly describe the coefficients, right? And then the coefficients by themselves are not very useful because they don't combine, they don't convey any magnitude effect or any sense of magnitude. How big are these effects, right? So I would recommend you to estimate elasticities or marginal effects or do some sort of simulation. I understand that for MDCV, there are no analytical solutions, but you can do some simulations to evaluate the elasticities and marginal effects. And in the case of attitudes, at least you could probably try, let's say, like assuming that everybody has the same attitudes of a specific socio-demographic group, and then what will happen to the outcome in that case. So that will give you an idea of the effects that we're talking about, because now you're only talking about effect direction and significance, right? So it's not really that interesting, I would say.
Thank you very much. About marginal effect, maybe in the next step, we will evaluate the marginal effects on different For example, the travel cost and the different other attributes.
Okay, so regarding other parts of the presentation, we also used Slovic's risk as a measurement in the past, and actually I posted in the chat, but in the case of Japan, it was surprising that we thought that we found that people considered COVID to be more dreadful than cancer, and also less controllable than a nuclear power plant. So we thought that there was some sort of availability bias. So there was a lot of COVID in the news, right, in 2020. So people just thought about that. Did you compare your indicators with other risks?
In this study, we mainly consider the indicators from the public transport actually, and incorporate these indicators in the model. Because we considered the risk events from different travel mode, but we think it will be very complex to put all of the indicators in this model. So we focus on the public transport.
No, I meant like not even if you don't put it in the model, just like a descriptive analysis. It would be interesting to see the relative importance that people put on different risks.
Yeah, I agree with you. Thank you.
Okay. Are there any other questions regarding this presentation? Still have some time. Okay, so I'll have one additional question, a final one. So your focus here is trip frequencies by mode, right? But have you considered purpose? Like I would assume that we found that in our study as well, right? So there were some differences. People were more likely to stop doing, let's say, like leisure activities or going out for drinks or eating out, but they will still need to do some grocery shopping, right? So there might be some differences there as well.
Do you mean the travel purpose?
Yes.
Actually, in this study, we mainly focus on the mode choice and the frequency choice, and about the travel purpose, we didn't consider it in this study. But I think it's a very important question. In our another study, we consider the travel purpose. Maybe we have further opportunities to discuss about it.
Okay. And finally, you didn't talk about the survey methods and sampling. So what was the target population? Was a probability sample? Can you say something about that?
You mean the screening questions?
So do you use a probability sample? Like a random sample? It was just like an internet-based survey, or?
Oh, sorry about the internet. I can't hear your question very clearly.
Okay, I'll put it in the chat.
Okay, thank you.
Let me just put it here. Basically, survey method and sampling.
Oh, okay. We use a web survey because we design to use both face-to-face and online survey method. But considering the safety problem, we only use the online survey to do to collect the data, and sampling is randomly selected through the residents among the Beijing residents, and we hired a survey company to do the collection work.
Okay.
Yeah.
Okay. Well, usually those are not those are convenient samples or quota samples, right? So probability, not really a probability sample, but I mean, we use the same because like it's not really that easy to capture, especially during the pandemic. Okay, if there are no other questions, I would like to wrap it up here. But are there any other questions? One last chance.
Oh, I do have a question. Can I just jump? Oh, about sampling, actually, that's a terrific question. Have this type of question have come out a lot in survey like this. So what's your understanding about this? Like, how do you guarantee a random sampling or a convenient sample? How do you actually interpret that, or can both you and the host, can both of you comment on this? It will be really helpful for me.
Okay, thank you much. Yeah, I agree with you that the sample is a very important question. What we usually do is to hire a professional survey company to do the sample work. And then in the data descriptive process, we will compare our sample with some other larger samples. I'm sorry I didn't show the descriptive results of the study, but we compared our sample descriptive with other works, and it works well. Thank you.
Okay, I have a little bit of a different perspective on that. I think because the problem with web surveys is like they don't have a representative sample, right? So those are self-selected surveys, so people just join voluntarily. So you have no idea about whether they have a representative sample or not. So I consider that a non-probability sample is basically a quota sample, right? So I mean, in this particular case, you know, I think the honest thing to do is to recognize in the paper that you're using a non-probability sample, and that the generalizability potential is limited, because otherwise, you know, you might mislead the reader in that sense. So I understand that there's a lot of limitations of doing a probability sample because it's expensive, and during the pandemic it was very difficult. But yeah, I can just be honest about it and say, like, this is what we have, and these are the limitations. Please do not read over these limitations, right? That will be my recommendation.
Yeah, agree. Thank you.
Okay, so if you don't know the questions, then I would like to wrap it up here. But again, feel free to post more questions in the chat. And Mr. Wang, thank you very much.
Thank you very much.
Okay, so we're gonna move to our last two presentations and our last presenter. So Ali, whenever you're ready, please share your screen.
Hello to all. I hope you are doing well. In this panel, in this part, I want to talk about validation of the inventory of driving related personality trait, IVPE.
Ali, can you put the full screen?
Yes. Do you have my voice?
Yes, I can hear you.
Yes. Okay. In my presentation, I'll focus on four major issues.
Ali, can you switch to slideshow, because are we only seeing the first slide?
Yes. What happened?
No,
yes.
I can only see I cannot see the presentation mode.
You cannot see?
Can you switch to presentation mode?
Yes,
so
yes.
I cannot see the full screen. I can only see the PowerPoint screen.
Yes. It's good.
There we go. Perfect.
Yes. In this part, I want to talk about validation of the inventory of driving related personality trait, IVPE. In my presentation, I'll focus on four major issues: research background, methodologies, finding, and conclusion.
Can you switch screens? I can see the presenter screen, not the full screen. So if you go to display settings, can you switch the?
I don't know what.
Now I can see the full screen, yeah.
Yes, it's good.
Yeah.
Yes. First and foremost, there is the question that why do researchers use self-report questionnaire to assess driver behavior and personality trait and crash history? The answers are increased interest in social psychological factors has also resulted in the increased use of self-reported methodology. Also, in self-report questionnaire answers are scored and analyzed based on the response, not, for example, according to the response time. Also, self-report questionnaire provide more detailed information than observation, and they can reach large number of people. Representativeness of the sample is easy to establish and can be measured with direct statistical comparison to driver population. Moreover, the reliability of items and measurement can be easily evaluated with standard statistics. As you see in this slide, if you search in a web browser, or for example in PubMed, self-reported questionnaire and psychology, self-reported questionnaire and accident, you understand that in this decade, these research are very grow and the slope is upward. Excuse me. Yes. For what kind of traffic research can self-reported be used? Attitude, opinion, belief, emotion, and cognitive process and behavior. And self-report are often misused, especially self-report of past accidents, near misses, mileages, and driver behavior that can be misleading or biased. Traffic safety researchers should treat the use of self-reported mileage, violation, and crash with extreme caution and preferably investigate this variable with the use of real information. What is the IVPE? The IVPE is used to capture the traffic psychologically relevant personality features of sensation seeking, social sense of responsibility, self-control, and emotional stability, all in the context of traffic psychological assessment. IVPE is a questionnaire developed by HELP to measure driving-related personality trait.
We're still on slide 4. Now, when you restarted the presentation, it's back to slide 4, so we cannot see the presentation.
I don't know why, what problem.
Maybe don't switch to presentation mode, but at least make the screen bigger.
Yes.
So we can see the full slide.
Is it good?
The slides, yeah, now it's okay. So if you remove, yeah, okay. So now it's a little bit bigger. You can maybe do it like that.
Yes.
Oh, excuse me. If you go to the right side bottom, there's a play your slide, the button. If you press that, then your slide will be going to full screen and we will see it.
Yes, thank you very much. The purpose of this study is to examine the psychometric properties, reliability, and validity of personality trait associated with driving in Iranian sample inventory. In addition, the internal consistency of the questionnaire has the same psychometric properties which have been obtained in studies conducted in other cultures. For this reason, the present study aimed to validate the Iranian version of IVPE within the framework of classical testing theory to gather the necessary evidence on the reliability and validity of the questionnaire in the context of Iranian culture. In this study, 366 offending or injured drivers were randomly selected, and the IVPE trait was distributed among them. To determine the test dimension, confirmatory factor analysis method, and for the internal consistency coefficient of the questionnaire, Cronbach's alpha coefficient, and for the retest coefficient of the questionnaire score, Pearson correlation coefficient, and for the relation between the question and the total question score, point biserial correlation coefficient, and for estimate the average performance of a statistical population, T-score was used. In the study of inferential statistics, the T-value and R-value of each question are presented. The result of table 2 indicate that the index of factor analysis doesn't have the desired fit index. Therefore, the question that didn't have appropriate T-value were omitted, and error covariance related to some item of the questionnaire was considered, and the confirmatory factor analysis was performed again as a modified model. In table 3, the fit index of the confirmatory factor analysis of the IVPE was reported. The results show fewer error values, but an inadequate fit of the model with the questionnaire data. And the conceptual model related to the standardized coefficient and the t-value are shown in figure 2 and figure 3. The result of table 4 indicate that all indexes have improved after model modification, and also all questions are significant at the level of 99%, which indicate that the items are consistent with the theoretical structure of the questionnaire. And table 5 shows that the fit indices of the confirmatory factor analysis of the inventory-related personality trait. The results showed fewer error values and good fit when it is compared to the original model of the questionnaire. And after examining the fit indices related to confirmatory factor analysis of IVPE, the conceptual model related to the standardized coefficient and t-value of the modified models are shown in the figure 5 and 4. To calculate the internal consistency between the item of the questionnaire, Cronbach's alpha was used, and the result of which are shown in table 6. And table 6 showed that the item of the questionnaire didn't have reliable internal correlation, and omitting each of these items doesn't significantly increase Cronbach's alpha. To determine the Cronbach's alpha of each factor, the Cronbach's alpha related to each component and the whole questionnaire are shown separately in table 7. Also in table 8, the results showed that some questions suffer from lack of discrimination power. And raw score should be converted to a standard score because a standard score, for example, T-score or Z-score, are more easily interpretable than raw score. Using the normal table and the raw score contain percentage, T-score and Z-score can be used for better comparison. And the results showed fewer error values and higher fit index value in the original model of IVPE. Also, the result of Cronbach's alpha showed that internal consistent of all scale was appropriate except two factors, responsibility and self-control, which didn't show adequate level of Cronbach's alpha. Thus, the IVPE was used in this study fairly satisfactory. And the IVPE in this study didn't have a good quality since the subject of the study were under pressure and the response was affected by stress. The quality of question used in the IVPE was not found adequate, while the quality of the question in the original version of the inventory was reported as highly adequate. This study had some limitation as follow. First, special limitation, and to evaluate the reliability of the questionnaire, only method Cronbach's alpha was used. 3, this study is limited to the offending and injured people aim to receive the third-party compensation from the insurance company. However, the response might be affected by the environmental condition. Thank you very much.
Thank you very much for that presentation. Are there any questions regarding Ali's first presentation? Okay, so I have 2 basic questions. I'm not that familiar with this kind of inventory. So what is this usually used for? So you said personality traits, and
Yes.
then how do you use this in transportation related policy making? Or
Yes, first of all, when you want to assess the drivers, the fundamental for personality is questionnaire, I think. After questionnaire assessment, you can use some, for example, hazard perception test. you can use some devices, and this is the comprehensive assessment for the drivers. The questionnaire is the fundamental step for the assessment of drivers. If you want to realize what kind of personality the drivers have, you should first ask them about their personality, about their behavior.
What kind of when you say it's an assessment of the drivers, but what are you assessing here?
Excuse me, please repeat your question.
So what are you assessing here? So you said that you're assessing the driver, right? But what do you want to know? How you do connect that to?
Yes, in this questionnaire, we assess the sensation seeking, self-control, and about stability. If you understand about the stability of drivers, you can understand about their driving behavior, that how behave in driving.
Okay, I understand now. Okay, so the other question is related to the previous presentation as well, run the sampling method, right? So how do you collect the sample?
Yes, it was randomly, and 366 drivers that were in insurance company were choose to fill the questionnaire.
So the sampling frame was what?
The sampling was randomly stratified sampling. Yes.
No, I mean the sampling frame. So it was a list where you pick the names, right? What was that document?
What was I didn't understand.
The sampling frame. So the document, the document that contains the population of interest from which you sampled your subjects.
Our sampling was applied in terms of objective and development in terms of method, and who were referred to the main branch of Asia Insurance Company in Bubble City, and were randomly selected, and then IVPE trade was distributed among them.
I'm writing in the chat, right? So that I wrote my question in the chat.
What was the sampling frame from which subject were randomly selected? The sampling was all of the driver in the bubble cities.
All of the drivers.
Yes, but okay. We choose the driver from the offending and injured from accidents.
Okay,
that they came to the insurance company.
Okay, I see now. So you have a document that contains the people already involved in accidents, and then you randomly sample from there.
Yes, because the drivers is under pressure and under stress, the validity and reliability of our questionnaire is under question.
Okay.
Because they are upset, they can't fill the questionnaire very well.
Okay, no, I just wanted to know what was the target population, but I think I understand now. Thank you. Are there any other questions regarding this presentation? Okay, if there are no more questions, then let's move on to your second presentation. But remember, you can still ask anything to any presenter in the chat. So yes. Let's go to the second one.
Start my.
Yes, please start the second one.
Yes.
Ali. can you switch screens? I can see your presenter screen.
Ali, we can't hear you. Are you able to talk?
I can ask him to unmute. Let me see if I can do it. Oh, there we go.
Yes. In this part, I want to talk about evaluating the impact of drivers' sensitivity to reward and punishment, personality disposition, and socio-demographic characteristic on individual accident proneness. Despite numerous research in traffic psychology on the association between various personality structure and accident involvement, only limited success has been realized. Crashes typically have several causes, and personality factor may be the starting point of crash sequence that culminate in disaster. Driver personality is reported as active determinant for risky driving behavior and accident liability. Cancer and Queering reported that people with personality disorder had an accident rate 144% higher than that of match control group. Concerning to route traffic safety, environment, climate, and weather condition, economic condition, vehicle quality, population density, human factors, psychological or physical, quality of roads, all play important role in traffic safety. Among the human factors, variables that receive less attention are personality trait, cognitive ergonomy, mental chronometry, and behavioral neuroscience. In the relationship between personality trait and risk of road traffic crash. In this research, we investigate the two theories of psychologists Hans Ising and Jeffrey Allen Gray because there are the linkage between accident probability and personality in their theories. According to Ising theory, the stable introverted individual are safe driver with positive attitude towards safety, and unstable extroverted are high risk driver with road rage, drink driving, or DUI, driving under influence. About regarding reinforcement sensitivity theory RST, there are two separate but interacting systems in the brain mammals that control emotional behavior and are the basis of personality differences. First is the BAS behavioral activation system, and second is BIS behavioral inhibition system. Also, we have another system, the flight freeze system shown in red, that we don't need in this system in this research, in this discussion. Also, we can say behavioral approach system or reward seeking or behavioral inhibition system, punishment avoiding. Gray's RST proposed the existence of neurobiologically based system underpinning the personality trait of neuroticism and extraversion. More specifically, Gray argued that neuroticism primarily reflects sensitivity to punishment, whereas extraversion primarily reflects sensitivity to reward, although they can lead to psychological dysfunction when any system is too dominant. In this figure, you can see that figure shows that the number of traffic fatalities was high in countries scoring high in extroversion. And a moderate amount of neuroticism seem to benefit traffic safety, whereas low and high scores on the factor N scale might increase the number of fatal traffic accidents. Finally, this study aims to generate a structural equation model of road accident in Iranian driver to better understand latent cognitive and behavioral factors influencing the reported crashes histories. It is hypothesized that personality trait all contribute to the reported crash history, and according to the general hypothesis, these factors affect the history of reported crash. Regarding data collection, the study used a stratified random sampling method, and the city of Babol was divided into 4 regions. And finally, 425 valid questionnaires were selected for modeling after the initial analysis. Icing personality questionnaire, sensitivity to punishment and reward, and Manchester driving questionnaire and safety attitude were completed by participants. And this part is very important, that 2 indicators were utilized to assess involvement of driver in road traffic accident: traffic violation index and accident index. In the first approach, according to the history of recorded traffic violation of each person, the corresponding statistic and information of the sample were collected using the Iranian traffic police reports. In the second approach, the information was obtained through a self-reported questionnaire, and the police and insurance record were used to check the driver's accident history so that self-reporting of crash data could be highly reliable. On the other hand, the official report didn't include some minor crashes, where drivers often don't report to the insurance company or police. That's why we included the 2 mentioned questions in the accident index to get more detailed information. This is our structural equation modeling and research structural model. In general, positive coefficient indicate a direct association between the latent and target variable, and also negative coefficient indicate that the inverse association. According to figure 2, introversion with coefficient of 248,000 had an inverse and significant on the crash history. In other words, introversion is associated with a lower expected reported crash history. But extroversion, neuroticism, psychoticism, and sensitivity to reward are associated with higher reported crash history. And sensitivity to punishment, demographics such as age and driving experience, and safety attitude or attitude towards safety and safe driving behavior is associated with lower reported crash history. In the present study, the value of both indicators revealed an acceptable internal consistency of the model according to the table 4. All the variable of the present model, the AV value is greater than or equal to 0.5. And all of the factors are appropriate in table 5 and table 6. The table 7 present the optimum value and those obtained from the structural model. According to the D7 indicator values, the proposed structural model has appropriate goodness of fit and a desirable predictive power. The result of the study showed that a strong association exists between these factors. And factors such as extroversion, neuroticism, psychoticism, and sensitivity to reward predict the higher reported crash history. On the other hand, introversion, sensitivity to punishment, positive attitude toward safety, low-risk driving behavior, age, and experience predict lower reported crash history and lower accident probability. Finally, the structural equation model was presented to identify the latent cognitive and behavioral associations with the reported crash history of Iranian drivers. And it is suggested to promote this study by evaluating the medical and behavioral cognitive skill of drivers, in addition to their psychological assessment using computer tests and driving simulation to analyze the effect of drivers' cognitive characteristic on the occurrence of road accident. Thank you very much.
Thank you very much for that presentation. So, first of all, going back to the first presentation, Kara has a question in the chat. So she wonders whether with the data that you have from the insurance companies, whether the 10% of drivers are responsible for more than 50% of the crashes or crash claims.
Yes. This is a different. Excuse me, if please read your question. The voice is weak. I think connection.
Sorry, I'm trying to not use the AC, so I'm using the fan. I'm just gonna repose Kara's question again on the chat. There you go. Can you read it?
I wonder if Ali knows whether 10% of the drivers were responsible. Yes, I think that the first step is this self-reported personality questionnaire, for example, driving behavior questionnaire, sensitivity to reward, and attitude towards safety that can be in the future. We use some devices and, for example, fleet management system or hazard perception test or medical or cognitive assessment with EEG or ERP to revise our results.
Okay, so do you think it's 10% of drivers are actually responsible for 50% of crashes?
I think that the main reason for the accident is cognitive ability of drivers and their personality filters.
Okay. So let's go on to your second presentation. So Jenna has a couple of questions there. So the first, I think back to your first presentation, she also commented that it might be good to link your study with automated vehicles and safety, because that might be maybe a long-term solution to the accident issue. But she asked, what is your main contribution for the second presentation?
This paper and research is different from that IVPE. This is we use Ising personality questionnaire, but in the last paper we use IVPE, and our sampling was different, and we used 4 questionnaire.
But
they aren't the same. Yes.
No, but I think she used a suggestion. I think that was like a suggestion, like a possible avenue of research. But the second question is the main contribution of this paper, right? So is this knowledge already discovered with previous research, or the main contribution is that you're retesting in the Iran context?
Yes, we retest in a new country. That means that in this paper we used a different sample and different driver, different participant. In the last paper, we just used offending and injured driver. But in this paper, a normal driver, the driver in the city, participate in our research.
But I think he refers to the state of the art in general, not in relation to your other paper, just in general to this field of study. Okay, but yes, do you want to answer that?
No, I'm at your service.
Okay.
We about how about question that about identify the extraversion, neuroticism, and psychoticism. We use Ising personality questionnaire. We
Okay.
use this questionnaire to assess neuroticism, extraversion, and psychoticism.
Okay, so I want to go talk a little bit about the model. So can you show the SEM slide where you show the diagram of the path?
Yes. We use a structural
Equations models, right?
yes.
So so I have two questions. The first question is like, what are the indicator variables that you used to estimate these latent variables, the ones that are in gray?
Yes, our latent variable was road accident, and our target variable was road accident, and our latent was introversion, extraversion, neuroticism, and psychoticism that we extracted from personality questionnaire, Ising personality questionnaire. Also, we have the driver behavior and safe driver behavior that extracted from Manchester driving behavior questionnaire, and sensitivity reward and sensitivity to punishment from Trobia questionnaire. These are our latent variables.
But road accident is not a latent variable, right?
What?
Road accident is not is an observed variable.
Road accident mean in this paper involvement in accident or reported crash history.
But it's observed, right? So usually in the path diagram we show them as a square, and then just leave the rounds for latent variable.
Yes,
so it's a little bit confusing.
relation is direct. For example, extraversion have a direct association with latent variable.
Yeah. So no, I mean I'm talking about the.
We didn't have a moderate variable in this model.
I'm talking about the graphic itself, right? So usually like observed variables are drawn as a square, not as a circle.
Yes. Oh, we can use. Your question is why we use circle?
No. It's not a question. It's a comment. Just like usually the convention is that round variables are latent and squares are observed. But yeah, so that's what I want to talk about. I want to talk about effect magnitude. So maybe if you zoom in here, you can see the effects. And then in the next slide, you talk in slide 18, I think, you talk about the main effects that you found.
Yes.
But I usually have a little bit of reservation with SEMs because like it's hard to interpret, right? Like you have a 0.59 coefficient. What does that mean in practical terms? Because your dependent variable is latent, right? So do you have anything regarding
the minus the minus component mean that had inverse relationship, and the plus and positive component mean that had a direct relationship. For example,
I understand that, but what does 0.24 means against 0.14 or 0.27, right? So when you talk about the magnitude of the effects, it's hard
these are impact factor and these are impact variable.
No,
for example, for extraversion, the 592,000 mean that extraversion was the main influencing variable that had direct association with target variable of the model. For example, driving behavior minus 422,000 mean that the safe driving behavior was the most important factor, which was inversely related to reported crash history.
Okay.
The amount shows that the relation is better. The association is better.
Yes, I agree with that, but what I'm trying to say is like the practical. I know it's big. I know the bigger number the better, but the practical interpretation it's usually a little bit fuzzy when it comes to SEM. So I wonder if you have anything regarding that, regarding the practical interpretation of the model.
Yes, of course. Yes, it means that, for example, in this model and the result, we showed that some latent factor and some, for example, target variable have a good relationship in the model. Also, we used this model assessment to show that our model is appropriate. The result showed that the relationship and the impact factor and the association is good.
Okay, so Jenna has another question on the chat. So she says, it's a little bit of a general question, but what are the main things that you look up when you have to check the fit or we have to evaluate on SEM, right? So yes. Maybe specifically in this table and probably the table afterwards. So what is it that you need to look at to evaluate the model?
We also, for this model, we use KMO and some of AVE and some of model assessment index to show that our model and factor analysis are good.
Okay. Okay, thank you very much. Are there any other questions regarding this presentation? And if not regarding this presentation, regarding any of the other presenters, we still have some time for discussion. Carla, do you want to elaborate on the last comment there?
I was just trying to reply to Jenna. I think SEM here stands for structural equations modeling. Is that right?
Yes.
Yes.
Got it. Yeah. So I also use spatial air models. So I just wanted to confirm that. Yeah, so structural equations is an economics thing, like you have demand and supply equations. So you have two equations and one is an input to the other and vice versa. Oftentimes that's endogenous equations. And so the air terms are not independent. So you have to do some special econometrics. Or you can just have a system of equations where they kind of look to be independent, but they are seemingly unrelated. And so there's just a variety of situations where you might have a vector of outputs. You know, you're asking a lot of questions like, how many crashes have you been in? How many like tickets have you gotten from the police? And so they're all related. And so you can have a system of equations and you can have only observed variables or you can have unobserved variables in the system, and they can share parameters if they, yeah, so it's pretty neat.
So I would like to follow up on that because recently my pet peeve or my obsession is effect magnitudes, right? And then especially for SEM, it's very fuzzy, right? Trying to interpret these kind of models because the variables are latent, so they don't have a scale. So when you say like, okay, 1 unit of a latent variable or even a 1 standard deviation of a latent variable, what does that mean? So I think it gets very tricky when you're trying to pin it down to effect magnitude, which is the original intent of my question. Sorry if it was not framed properly. But yeah, so I don't know, I always go back and forth whether SEMs, I mean, they're good because you can analyze a lot of stuff, but then it's really hard to interpret.
Yeah, I'm not a fan. I think it's mostly in the humanities where you have some people that just throw, you know, a computer at these things and try to guess at what the latent constructs are in there. They're like attitudes that you can't observe, but you can try to infer, and they're in the middle. It's sort of like a set of neurons, you know, in a neural network that are there in the middle. So yeah, I never really do that. I don't find it particularly useful.
I tried it once and then I was like, I think I ended up more confused and I was like, wait, so okay, I did this and I estimated, but then what does this mean? So recently I've been thinking about, like, before I do any analysis, interpretation, right? So
yeah. I mean, it's the data that drives the way I set up my models. So that leads to a lot of new models because you just can't, defend the existing models that are out there. And I think you'll be able to do that, Giancarlos. So, just really consider what's happening and what you need. For example, when I was a master's student, we had all these variables about neighborhoods. We had like 100 variables. We had sidewalk width and distance between light poles and tree vegetative cover and all these variables. And we were able to use factor analysis, which is a simple form of structural equations models, factor analysis to kind of distill all those variables into a few major variables. And so you might find that helpful sometimes. So it really was the situation that drove us to the method.
Yeah, PCA as well, like linear though, so like allows you to like reduce the dimensionality.
Exactly.
I think that SEM has good shape. You can understand in simple way. And in my paper, I talk about the structural equation model very much. And I explain all of the relationship and what is the, for example, structural equation modeling and how we should use this model.
So maybe you should forward that to Jenna, because I think her question is exactly how to evaluate models, right? So I think that's what she's asking around 1240, 1239.
Yeah,
Okay.
Thank you. Very helpful. Mm-hmm.
So are there any other questions?
It's not a question, but I can tell you I'm very extroverted, and so is my son. And he's been in 2 crashes already. He's only been driving for 2 years.
His sensation seeking is very high.
But yeah, we're not really neurotic or psychotic. So I've only been in 1 crash, but I could definitely see myself. My husband always worries I'm going to crash more often than I do because I'm a pretty aggressive driver. I like to get places quickly, I'm not worried about the car. So my husband doesn't want me driving the Tesla. So I drive the Prius.
In Ising's theory, the person who has extroverted personality trait, and in Gray's theory, who has behavioral activation system, higher behavioral activation system, or more accident proneness. Also in Ising's theory, introverted person, and in Gray's theory, the person who has a lower behavioral inhibition system or less accident proneness.
Right. Yeah, it definitely makes sense.
So what would be the applicability of this? Because like I think from the perspective maybe of the if I'm an insurance company, maybe like I will raise the prime for like neurotic persons or extroverted, but like you cannot forbid anybody to have a license just because they have a higher likelihood of crashing, right? So yes. when you talk about like policy implications, what would be the way to connect that to crash reductions?
Yes, in the future we can use this model and for human patterns in connected and autonomous vehicle. We can use this pattern about personality or cognitive abilities that for future work we use in connected and autonomous vehicle to design a better pattern for these driverless cars.
But wouldn't the automated vehicle eliminate the personality issue altogether, because cars don't have a personality, so they will technically.
The pattern is very important. The pattern, for example, we have many patterns. For example, extroverted persons have different vision with introverted person, and this is very important in driving and about the light of the car.
No, but if you have like a fully automated level 5 vehicle, then the personality issue just disappears altogether, right?
I have a comment on that actually. So I read something on Nature Science the other day. People are talking about machine behavior because all these neural network or these deep black boxes, machine may have a personality one day because I mean it's all driven by codes and could has issue. So maybe there's a I don't know, machine behavior, and then machine may have extroversion personality machine, or this is me just thinking about it out loud, but then maybe not.
That will be scary. It's interesting, but that's scary. But
What's
yeah,
the
like,
human-vehicle
they
interaction,
learn-
for example, for unprotected and protected road user, for example, pedestrian, and for recognize the pedestrian behavior, should be maybe it's good for this pattern, for example.
Okay, I see. Yeah, that's true. Well, I don't even have a driver's license, so I don't have a lot of input here. But are there any other questions? Okay, if not, I think it's okay. We can wrap up 10 minutes early to give time for the next session to prepare. So thank you all for joining, and please enjoy the next session on, I want to say, emerging research, right, Yasmin?
Yes, that's correct.
Okay, so emerging research is gonna come next, so please stay tuned. And thank you all for joining and for all the questions.
Thank you, Giancarlos.
Very much.
Shams, can I start sharing my screen, do you reckon, or do you have slides for yourself? Whatever you feel.
Mute. I'm talking, but I'm on mute. I have a couple of slides. That's
good. Yeah,
but
then
like, yes, those I don't need to share because it's just information about like how many presentations we have. I'll just like read it out, and then it would be great if you actually can share your slide. It's
okay. But yeah, because we are early, so we are about like 3 minutes.
Yes, we are ready. Yes, I'm just seeing we have Andre will join at 3.
Yes,
Chen is already here. That's great. And we have Bhuvana Chitra. I cannot see her yet, but yeah, we have 2 presentations before she could join. Are you teaching any course this semester?
Yes, I am. I had one full course, which is operation research course,
right?
Digitalisation operation research. Then I had a half of a course which is about environmental sustainability, environmental transport and environment. So it's about air pollution, emission estimations, dispersion model, those noise and etc. And then I had a couple of other sessions on a project design.
All right.
Yes, it was a very crazy teaching.
Yes. Yeah.
How about you? Do you teach this time?
I don't know. I don't have any teaching load. I just do teach a couple of classes for advanced engineering course. But I have kind of like introduced not necessarily a course. It's I call it workshop, but it's kind of like, you know, audit course for grad student on discrete choice model.
Oh yeah, that's good. No, I kind of got caught by surprise with this COVID, because last Friday when I was leaving my office, I felt that I'm okay. I just felt a bit exhausted. That was all. And then I forgot to bring all of my, HDMI cable connection, pen, and everything, because I thought that I come back to office on Monday.
Yeah.
And then just on Friday night, then I realized that my symptoms actually started developing, and then I got so my rats came positive, and then I had to isolate myself. So I was thinking, oh gosh, even I can't connect my laptop to monitor, or even like the jackpot on the voice, it doesn't work on my laptop because it's it needs cables and connectors that I left all in my room. So there's a bit of situation here.
Yes, I understand that.
Yeah, so let me actually start sharing my screen.
Yes, please do that. And it's already 2 p.m. just 2 p.m. We'll just wait for one.
Yeah, we can wait. Yes.
Just 1 minute and we'll start after that.
Yes. Yeah, definitely.
I got COVID. I went to an event and I think I got it from there. But for 2-3 days, there wasn't any symptom. And suddenly on a Friday, I started to feel, pain, just headache here and there, pain. And I thought, okay, perhaps I have COVID. The next day I tested, nothing, but the day after it was positive.
Yeah. Yeah, I still have a very heavy head, so my head is a bit. At least I got actually 2 painkillers right now.
Yeah.
So,
yeah.
Yeah,
I hope you can take some rest after this, and thanks God that the next 2 days are weekend, so you can take rest.
Yes.
We'll just start, given that it's already 2. p.m. and we have 5 presentations. Hello, everyone. Thank you very much for joining us today. And thank you for, I do welcome you to the 4th Bridging Transportation Research Conference. I think some of you were already in the last session. Thank you for joining. And the theme of this session is emerging research. We have 5 different presentations ranging from air travel demand, activity travel demand, ride sharing demand, then also the freight transport and also effect of travel behavior on COVID-19. So we will get to see different kind of dimensions of transport research, starting from road transport, air transport, and freight transport also. So it will be very interesting. I hope so. Some just housekeeping. Each presenter will present for 15 minutes, and after that we are going to have 5 minutes, 4 to 5 minutes Q&A session for each presenter. And I would appreciate if you could kindly write down your question in the chat, or if you want to spell it out, just raise your hand, and I would request you to spell out the question. And I will just time for each presenter that 15-minute time period. After 14 minutes, I'll just notify the presenter that we are at the 14-minute timeline. And at the end of the 5 presentations, we might have 5-6 minutes extra. We will try and answer. If there is any outstanding question, we'll ask the presenters and request to answer that. But other than that, the audience are most welcome to reach out the presenters over email and in any other platform possible. So we will get started. Our first presenter is Dr. Elnaz Irannezhad. Please pardon if I am not pronouncing the name correct.
It was quite correct.
Thank you very much. She's a senior lecturer of transport in the School of Civil and Environmental Engineering at University of New South Wales, and her expertise are her research contributes to the advancement of science in cross-disciplinary fields, including logistics, supply chain, blockchain, mobility as a service, also automated vehicle, and agent-based modeling. And today she will talk about integration of blockchain and Internet of Things. Ili, the floor is yours. Please go ahead.
Okay, great. Thank you, Shams, and thank you everyone for listening to my presentation. I would like to acknowledge my co-author, Dr. Hamid Faroqi, who is now a postdoc at American University. It was actually a joint effort by 2 of us, but then I had the opportunity to present on behalf of both of us. So it's about a research paper that we published in 2019. We actually did that in 2019 during my postdoctoral research, which was mostly on blockchain, and we also looked at IoT. So, excuse me. Digitalization in freight transport has revolutionized many parts of freight transport in terms of enabling benchmarking, monitoring, managing, analyzing, forecasting, because now the freight data are recorded digitally in digital platforms at company levels. But then we also see that still there are some inefficiencies with the current digital platforms. And actually my presentation is about a conceptual framework that how with the integration of IoT and blockchain, we may be able to solve some of these inefficiencies that still we have with the current digital freight transport platforms. So I will dissect it in the next slides. At this slide, I put a schematic overview of import and export supply chain. And you can see that, well, it's a very, very simplified schematic diagram of different transactions. And there are actually 2 different layers of transactions. One layer is a physical movements of shipments and containers, and the other layer is the administrative layer, which has either liability, contracting, financial contracting transactions. So the physical movements, for instance, I show it in purple dotted arrows, whereas the other administrative contracting stuff in gray dotted arrows, and it's again very simplified version, but that's something that in terms of all of these contracting and transactions, these are the things that usually are hidden from the third person outside of the system. Based on my experience during my PhD and my postdoc, I got to know that there are still so many inefficiencies and invisibilities in terms of all of these contracting and transactions. And that was why actually motivated me to undertake this study. So I looked at actually the World Bank statistics in terms of the efficiency and the performance of Australian ports. And unfortunately, we are not doing great. We are actually on the bottom 25% of worst performing container ports in the world. And it shows that there are lots of rooms for improvement, definitely. And in my next slides, hopefully you can also see some of those inefficiencies. So we actually, it kind of, that level of inefficiency kind of hitting the exporters, importers, and Australian trade as well. That this news actually was from March just this year. And, you know, after COVID, with that, all of the imbalance of import-export containers, waiting in Chinese seas and etc., then the cost is at very at worse situation, so that some of these even freight transport companies are feeling bankrupt. So it's definitely an indicator that there are some inefficiencies involved, that we are doing very bad. So I started actually looking at what are the value chain analysis, what are those kind of inefficiencies. And the first step for that in my research was to basically dissect all of the supply chain. And the table that I put here, I'm pretty sure, I'm so sorry that actually it's not readable for you, but the reason that I put it there is just basically giving you some kind of overview that even like before loading a ship, you can see there are lots of transactions and interactions between different agents like exporters, shipping line, empty container park, distributors, packers, road carriers. And there are lots of these transactions, and like one by one, like peer transactions, and there are lots of inefficiencies involved. So the first step was understanding what are those interactions, and then quantifying some of those inefficiencies. Just if I put it as a very short bullet points, in the absence of digitalization, if there is no digital platform to manage all of these transactions, then there are lots of communications that will be done manually, even over the phone, or will be just email, and no email will not be considered digital, definitely. So there are also long trail of paperwork, which is estimated to be around like 15 up to 50% of the cost of the physical transport worldwide. And you should know that the cost of physical, the cost of actually transporting a container itself is multi-million dollars. There are lots of data discrepancies, human mistakes, double spending, double booking, forgotten booking, lots of disputes over unexpected cost and delay. If, for instance, ship has a delay, then it is not really clear who is responsible for that delay. Or, for instance, if the shipment make it to the ship to get loaded on the ship, then it's not really clear that what was the reason of the delay, who is the responsible, who is the owner of the shipment at that time. And there are also lots of middlemen involved that they impose extra costs, like, for instance, freight forwarders, brokers, customs brokers, and so on. And it was surprising for me when I started doing this research, understanding that even like in Australia, freight transports, they do lots of their communications through this just email and phone communications, and these are basically some of the inefficiencies that I heard it from firsthand. Some of these companies, for instance, big companies like Toll or Shipping Line, Maersk, some of the international companies, they have digital platforms, but then their platform is siloed. With the silo digitalization, then it means that the digital information reside on the location of the owner of that digital platform. So yes, it brings intra-organizational efficiency, but then in terms of the information asymmetry and lack of visibility still is there. It was also believed that lack of trustable and unique source of proof again leads to disputes. So even if it is in a digital platform of one company, but because there's not enough transparency across the whole supply chain, then still those disputes would remain unresolved. And again, middleman as well. So I started actually by quantifying at the inefficiencies at each leg of the supply chain, and I kind of summarize it in this table. I invite you to read the paper later on. I can, for the sake of time, I cannot go through these things. So before loading, after loading, there are multiple type of inefficiencies and uncertainties that led me to think that we need something like EDI. And yes, actually we have EDI, we have electronic data interchange protocols, and from the EDI, actually it basically it consists of 4 layers. One is a computer system for exchanging electronic transaction, a web-based EDI tool that translates your accounting information into the EDI format. Then we have EDI mapping that syncs your accounting system to your customer system or to another organization system. And then transaction network sends and receives transactions. And there is also always one, ongoing maintenance and services of EDI. But in Australia, for instance, in terms of import and export, we have one stop, which is kind of provides that EDR communication between the truckies and stevedores, container terminals. But then one stop is not integrated into empty container terminals. It's not integrated to the digital platform of exporters, importers, customs. So again, there's lack of enough integration, and one stop actually is now itself is like a middleman. So they hold the data. They're kind of owned by container terminals. Their container terminals are their shareholders, but then they don't really share the data with transport companies, with exporters, and still some of those inefficiencies cannot really be quantified and measured. So what some other ports across the world they've done is port community system, and port community system is basically a digital a decision support system, a centralized decision support system that can that everyone, if they have any like shipment to be shipped or all the documents, then they have to lodge it through this port community system, and it integrates all of these actors, and also can provide some business intelligence in terms of offering the optimized logistics solution and real-time situation of the containers and so on. So all of the delay and everything, that it can be at least more transparent, and it resolves lots of those dispute issues. But then the problem is port community system is really has been successful in the government ports, for instance, in Port of Rotterdam, whereas the Australian ports, the 5 major Australian ports, there are landlord ports. So there's lack of authority over freight operators from the port side to encourage them to use such a centralized system. And there will be also a huge cost of launching this platform, maintaining it, and when basically ports just lease their land, there's not enough motivation for them to get involved in such a huge costly initiative. There are lots of hacking threats and so on that we saw that in it happened to Maersk last year as well, that it kind of paralyzed 2 days. So these are some of the issues and concerns that I started realizing that is not perhaps a solution for Australian ports. And what was the solution? So basically I came up with blockchain. I mean, I didn't come up. I just realized that blockchain could solve some of these concerns. And what is actually blockchain? Basically, blockchain is an encrypted, decentralized, open source platform. And the backbone technologies of blockchain aren't new. Blockchain actually combines cryptography with distributed system technology and peer-to-peer networking technologies. And it has been around for 2 or 3 decades. But there are lots of marketing hype around it. There's lots of unsubstantiated claims that what blockchain can do or what can't do. But it is worth actually mentioning that what differentiates blockchain from a shared distributed database is that it solves the who problem. So it solves the who problem in terms of who owns the data, who is allowed to edit or change or delete the data, who creates the database and maintain it. So that these things actually remove the middleman, and that was why that we thought for such a port community system, then blockchain could be a solution. And in the next slide, then I will explain it to you that how does it really work, although actually it's not really feasible doing it in 15 minutes. So I encourage you also to read my paper here that I try to answer a few research questions in terms of blockchain and different blockchain architectures. So I encourage you to read that later on. I just skip that part. So in the talk that I wanted to tell you about is actually integrating of blockchain with IoT. And the IoT devices are typically actually connected to computer with Wi-Fi or with mobile with data. And they use sensors to measure specific aspects, for instance, humidity, location, light level, if the door of the container has been closed or not, speed of movement, several different sensors that we can actually integrate and we can utilize so that we can make sure the integrity of the container, of the physical shipment, as well as the integrity of all of the transactions can be held through the supply chain. There are some challenges with IoT devices itself. They have capacity throughput problem. Hacking threat is a big thing for this. So that is why that it would be always useful to integrate IoT with blockchain so that we can circumvent some of these challenges. So that's kind of oh yeah, I have to kind of wrap it up, right?
Yes.
Yes. So let me just wrap it up very, very quickly. So basically, the conceptual framework that I wanted to present is I again encourage interested readers to read the article. It's a very long paper, but basically how it works, the physical world of IoT is integrated with the cyber world, the sensor data and transaction verifications. So all of them, then we also have different protocols on the blockchain layer, like the privacy protocol, we have public ID and private ID, and they're all both cryptographed or hashed. And from hashing, I mean that with any changes in the transaction within the contract, then the avalanche effect of the hashing or that cryptography algorithm makes actually flags it out as the manipulated data. So once actually that the transaction is not manipulated and everything is all right, and again, the public ID is just revealed, but a public ID actually is linked to a private ID with some XOR bitwise coding or something, some of the algorithms that I explained in the paper. But then they are validated through several nodes and on the blockchain network that could be all of these shipping line and freight transport companies. And then once the transaction is validated by a consensus mechanism, and in this paper we suggest a proof of stake for such a use case, then this transaction is linked to the previous block, to the previous transactions, and all of those with the heading of the parent blocks, they're also again combine and become as a new header for the new transaction. So they're all like links, like as blocks to each other, so that it cannot be manipulated aggressively. And definitely at the end, we need an end user dashboard with some service APIs, because not everyone actually is familiar with blockchain and all of these things. So in terms of the performance and how freight transport companies actually they use this end user dashboard, which is linked. So in the paper, actually, we explained just these two things, and that's my last slide, Shams. So we presented actually two big issues on, two examples of a big issue in supply chain, which is about the bill of lading. And I have provided two court cases here that happened in 2017 and 1991. And the reason that it happened, if you read the paper, then you will understand that it was because of double spending, actually double contracting. And double contracting was kind of led by the freight forwarders to kind of masquerade some information. And then in the paper, then we explained that if you combine IoT with blockchain in each stage of the supply chain, then you can have the holder of the shipment and how you can actually avoid such circumstances. So sorry for the long presentation. I stop it here.
Thank you very much, Lee. We have time for one question, and totally a blockchain beginner, but we have one question from Parady. He's asking, totally a blockchain beginner, but what happens if error, say input error, intentional or deliberate, are introduced in the blockchain ledger, and how are transactions validated automatically? Don't you still need some sort of automatically approved platform?
Yes.
I'm a bit confused as to extent this allowed to automate operations.
Yes,
do you mind answer that?
Yes, thank you. That's a very great question. Exactly. So in the let me just bring that up. Well, first of all, in terms of the hashing that I said, so if any changes later on a contract or on any kind of transaction, it happens, if someone just makes that change, then it changes everything on that it changes actually the heading of the transaction, because because the transaction is a combination of the hashed of the the identifier plus the sensor ID plus, you know, these are all integrated and then become one full length. For instance, 256 bit is the Bitcoin change, right? So if any changes later on be made on the transaction, then it will change the heading, and then it cannot be linked to the previous transactions. So basically it kind of flags it out. Otherwise, in terms of some mistakes, so basically smart contract is one of the also the other useful features of blockchain, that it's a kind of if-then rule, that you translate all of those contracts into if-then rules, computer programs. And for instance, here I put one example of this smart contract for verification at the smart gate when the container arrives. So if the door sensor shows that it hasn't been opened, inside the container hasn't been changed, the weight as well. So that's sort of, you know, kind of automating all of the transactions so that also all of these mistakes can be avoided.
That's great. I have some questions, but we will catch up those on at the end of all the presentations. Thank you, Ellie, for your nice presentation. And I know that in Australia we do have very big challenge in any sort of freight data. We don't have any commodity flow survey data, so we have definitely a lot to talk about. I'll move on to our next presenter. Hi, Sally, could you please kindly share your screen? So the next presenter is Sally Chen. She is a third-year PhD candidate in civil and environmental engineering from MIT. She's working under the supervision of Professor Moshe Ben-Akiva, and she has completed her master's most recently in May 2020. So she has, she is working in developing demand model specifically focusing on air mobility. Today, she will talk about demand analysis of urban air mobility. So Chen, please, the floor is yours and get started. You have 15 minutes, okay?
Okay, great. Thank you, everyone. It is my great honor to be here to present our research on demand analysis of urban air mobility. And again, I'm a third-year PhD candidate at MIT Intelligent Transportation Systems Lab. I'm working under the supervision of Professor Moshe Ben-Akiva. So in this presentation, I will be covering these following sections. Start with a brief overview, then talking about our methodology, the results, and then finally the conclusion that we draw. So first of all, a brief background of urban air mobility, or UAM. So sometimes we might call it flying car or air taxi, but this is actually an idea that's not that new. It can even be traced back to the last century in 1917, when the first flying car was invented by a man called Glenn Curtis, which is this picture you can see here. But because of all the technical and regulatory constraints, these never went into mass production. And later in 1950s to late 1980s, we actually start seeing some scheduled helicopter services operating in major US cities. But there's still a lot of challenges, for example, the safety and the fuel cost. So because of that, these kind of early helicopter services still cease the operations. Now, until today, from 2010s to present, now we have all these technological development in automation, electrification, communications. We now see the rise of this idea of UAM again as an on-demand service or air taxi. So these UAM services, they use the electric vertical takeoff and landing aircraft, or the eVTOL aircrafts, to transport passengers from point to point on demand. And these eVTOL aircrafts, they travel between the vertiports, which are basically the stations for these aircrafts to take off and land. So the US Federal Aviation Administration says that UAM is a safe and efficient aviation transportation system. So it really has this great potential to alleviate the congestion and emissions in urban areas. But of course, as a new emerging mode, there are a lot of uncertainties that need to be addressed. Specifically in our research, we focus on analyzing the system-wide impacts of UAM on transportation demand. And to be more specific, we focus on the user composition of the UAM users, for example, the income distribution of the UAM users. And second, the market by different trip characteristics, for example, market penetration by trip distance. And we also want to analyze the impacts of supply configurations on all of these above. So the scope of our work is to focus on 2 real North American metropolitan areas to analyze their UAM potential demand. And second is to also consider the uncertainties on both the demand and the supply side. Broadly, our methodology is to apply an agent-based simulation laboratory by expanding an existing simulation platform, Simability, which, as you can see from this logo here, it has been developed by our lab in the past several years. And in this UAM research, we extended that to model the UAM demand, supply, as well as their interactions. And in the following slides, I'll talk in more details about our methodology. Okay. So to begin with, I would like to first introduce in more detail about our simulation laboratory, Simability. As I mentioned before, it is an activity and agent-based simulation laboratory that has been developed by the ITS lab before. It mimics the real world with different components varied by time scale, for example, from a short term to a long term and a midterm. And in this research, we focus on using the Simability midterm component. And then on the right shows the flowchart of the Simability midterm component. And there are 4 major modules, which are highlighted in the red boxes. We have this pre-day module, which is an activity-based model system that models agents' decisions on daily activity travel plan. So what kind of activities should be generated and then what kind of mode destination they should choose. And second is the within-day component within the module, which models the execution of the plans. Follow that, we have a supply module to simulate the traffic movements in the network. And lastly, because we want to capture the demand and supply interactions, there is this day-to-day learning process that iteratively simulates all of these components until we reach an equilibrium state. So to study UAM in this research project, all of these 4 modules have been extended. To begin with, I would like to first talk about the extension with the pre-day component, which again models decisions on the day activity travel plan. And the model has the structure that is shown on the right of this figure. So to begin with, we have this baseline choice model that is on the top. And this baseline choice model is basically the existing mode and mode destination choice model that we have in Simability pre-day. Based on that, we extended with 2 models. One is a consideration model that's in the blue box. Another one is a switching model. And they have different functionalities. The consideration models agents' decisions of whether to consider UAM or not. But on the other hand, the switching model models decisions of whether to actually switch to UAM or not, given that the agent will consider the UAM alternatives. Specifically for the consideration model, we have 2 steps. One is a heuristic availability check, which, as the name suggests, checks against a bunch of heuristics. For example, the service availability of UAM, which could be dependent on the aircraft range. And second is a willingness to pay based consideration that computes the extra cost and time saving. And following that, only those that pass the check and have non-negative willingness to pay are then set to be available in the switching model. And for the switching model, we have 2 stages of decisions that need to be made. The first decision will look at all of the UAM alternative and decide which one is the best. In the second stage, then, an agent will make a binary decision between the best UAM alternative and the alternative that has been chosen from the baseline choice model. Overall, we consider 4 UAM access egress mode to or from the vertiport: the park and fly, kiss and fly, MOD and fly, and lastly, PT walk and fly. So after the agent make their day activity travel plan would then go into the within day model to model their decisions on how they want to execute their plan. For UAM, we consider two kind of execution decisions. One is the route choice, and the second one is access egress mode decisions, which has an overlap with the pre-day model. So let's begin by talking about the route choice decision. For this, we build a UAM network which integrates the ground nodes, the ground network with the vertiports. So you can see a very simple graph here that shows the structure. We have these red squares that present the UAM nodes, which symbolize where the vertiports are. And also the black dots, they represent the ground nodes that already exist. And based on these networks, we can then compute the shortest paths for the route choice model. So that's the first thing we need to do in within day. The second is the access egress mode decision. Now, as I mentioned before, in pre-day during the planning phase, the agent will only decide they will decide their access egress mode, but it is only a high level preference. Now, it is only during their execution in within the model, then they will determine the specific mode to use. Here, we also decide that based on the heuristic preference hierarchy. So for example, for an agent that decide to use park and fly, which model a combination of drive alone and UAM, if the car is found to be not parked nearby the destination vertiport, which means that the egress trip with drive alone is not available, then with the preference hierarchy, we'll then apply MOD for the agent. So that covers the modeling part we have for the demand side. For the supply side, we developed a UAM controller, which coordinates between the passenger and the UAM aircrafts. The UAM controller, it matches the passenger requests to the aircrafts. And second, it tracks the UAM aircraft states. The states include the charging state, how much battery is left, the capacity of the seat, and to schedule their tasks. And thirdly, the controller is also responsible for managing the priority queues at the vertiport. So the stations that the UAM take off and land. The queues are implemented to manage the takeoff and landing. And lastly, we also implemented the rebalancing function in order to proactively serve the demand. Now, the last step in our modeling is to interact the demand and supply model throughout this day-to-day learning process. So both the demand side and supply side will learn the attributes to update their actions until we reach an equilibrium state. So for example, on the passenger side for the demand model, we will learn we'll not only learn the travel time and cost of the ground transportation, like the public transit, drive alone, carpooling, etc. We'll also learn the UAM passenger waiting time so that the passenger can decide whether UAM is actually beneficial or not. All right, so that covers the simulation laboratory that we extended. And specific for the scenario that we did, the objective here with the scenario design is to analyze the impacts of the supply configurations on the demand. So we consider three kinds of supply configurations. One is the price, second is accessibility to the vertiport, and lastly is the capacity of the vertiport. We also consider uncertainties in both demand and supply side. For the demand side, the uncertainties, we consider that by based on the reported standard errors of the parameters we used from existing studies. As in terms of the supply uncertainty, we consider that based on the price and aircraft specifications. And this table here summarizes the scenario design we have, which I don't have time to go into the detail. But in general, our scenario, we try to set up a scenario to model the situation we might have from at launch to near term to long term. So the study area, based on our previous research done by our lab, the major cities worldwide has been clustered into 12 typologies. The factors include the mode share, economic, things like that. And then you can see the factors in this spider network here as well. And So from those 12 typologies, we selected 2 real North American cities, which are called Auto Innovative AI and Auto Sprawl AS. And then they have different, both of them are highly industrialized and car driven, but some of these factors have different scoring. After we selected the real cities, we can then locate the vertiports where we want to place them and also to generate their capacities. For the vertiport selection, it is an iterative process adjusted to the simulated demand that we have. And at the same time, we also compare that to the scenario accessibility measure we set up so that we do not exceed the accessibility that we want. In terms of the vertiport layout, it is also based on real geography, based on the space that we can see on the map. And based on the real space we have, we can then select the number of facilities from available vertiport designs. And specifically, we are using this figure that we are showing here. And finally, let me now present some results. So the first thing we look at is the penetration rate across all the scenarios, which is shown in this figure here from at launch to near term and then to the long-term scenario. So first, looking at the at launch scenario, it is pretty obvious that the potential UAM market is quite niche. So the average point here we have is below 0.2% in both of these 2 cities. But in the long term, we are seeing more demand. And comparing these 2 cities, the penetration rate is higher in AI than in AS, which could be explained by the fact that AI has a higher income distribution and a higher congestion level. And from a launch to long-term scenario, we're seeing increasing uncertainties. Now, in terms of the model shift, access egress mode, the left figure shows the model shift result, and then the right one shows the access egress mode share. So overall, looking at these 2 set of results, the observation we have is that potential UAM travelers are mainly the car-oriented individuals. So most of the switching come from the drive-alone trips, but they would still want to use their personal vehicle for the access and egress trips. In terms of the UAM user distributions, income distributions, here we also show the result for AI and AS. So the first thing is by comparing the scenario results with the population distribution, we see that the majority of the UAM users belong to the high income households. Therefore, this indicates that we have this equity issue with UAM. And is this more severe in AI than in AS? On the left is AI. Now, comparing from a launch to near-term scenario, what we changed in the scenario design is an increased capacity. And we are...
Chen?
Yes.
Okay.
Okay, sure. I will wrap up quickly. So here we increase capacity, but what we are observing is that the share of the high-income individual increases. So this indicates that the equity issue exacerbates. But then when we increase, when we go from near-term to long-term by increasing accessibility and reduce the pricing, we see that we show sign that the equity issue is alleviated. And lastly, the market size by the flight distance. On the left, it shows the UAM flight distance distribution, and on the right shows the market penetration. So even though we are seeing that the market penetration by the long-range trips is higher, but the majority of the UAM trips are still short-range trips, given that we don't have that much long-range demand in an urban setting. Okay, finally, to conclude this presentation, we analyzed the system-wide impacts of UAM on transportation demand by extending a simulation platform to model the UAM demand, supply, and their interactions. Some of the key takeaways: first, UAM is a potentially niche market. Second, equity issue exists with UAM, and even in the long term, different supply configurations can have different effects. And thirdly, the majority of the potential UAM users are found to be car-oriented. And given that most would want to use car for their access and egress, there exists this need to evaluate parking infrastructure demand around the vertiports to avoid the congestion around vertiports. And lastly, the majority of the potential trips are found to be short-range trips, but there is literature that says that short-range trips may be less energy efficient. So the environmental impacts of UAM should also be systematically studied in the future. And that concludes my presentation. Thank you for listening.
Thank you very much, Chen. That was a very nice presentation, and it's always good to see how things might evolve in the future when we are going to have even more emerging transport system. Does anybody have any question for Chen? I don't see anything in the chat box. We will open up the question floor once all the presentations are done, but at this stage I'll ask you. Yes, please.
I wrote one in the chat box about the network.
All right. Okay. All right. Yes. Okay. Yes, there's one question. So, how is the air network defined? And are there areas where vehicles cannot fly over, that is like city center and scenario areas? So the path of the flight. Would you mind to answer that? Yes.
Yeah, that is a really good question. So we actually considered how to design the area networks, because you can imagine in the area you can also have different lane, and different lane have different capacities, speed limit, etc. But as I mentioned, in this project, we focus on the demand analysis of UAM. So we simplify the supply side, the network design. If I go back a little bit, our network is a simple, fully connected graph. So we, the short answer to that is we did not consider that, but it's just everything you have the shortest, the path connected, the direct link. But that is a great area of study.
That's great. Thank you. We have another question from Javier. And the question is, how far do you think we are from operational UAM?
I don't want to make a wild guess, but there's some news that you can find out. For example, a leading company in the US, which is called Joby Aviation, they are trying to have their UAM service out there by 2024, as far as I can remember. And so I think that's the nearest I think we will see this. But in fact, there has actually been some companies operating UAM services. I think the name was called VOOM. They operated before, but then ceased the operation because of COVID. So there are things out there. It is, yeah. But in terms of like mass operations, I'm not sure.
Okay, thank you. Do we have Bhuban Chitra online? No, I don't see her. So we will carry on with the question for a couple of more minutes. Another question that we have from Parady. So the question is the UAM market regulated at this moment in terms of the fly space and such?
Yeah, so in terms of the regulation, there are existing regulations on airspace restriction to fly in the cities. For UAM, I believe this is an emerging topic that the industry, government are trying to look at, as well as some researchers. But I'm not that familiar with this area of studies.
Thank you very much. I have a lot of questions. All right. I will start with one question about the cost function, the price that you have. So I think it's system generated, but was it somehow computed from any trade-off calculations, just trying to understand why people is going to opt for the modal shift? So was it just computed by calculating the trade-off computation for price that we usually do, or was it just system generated?
So if by trade-off, if you mean like comparing the extra cost for time saving, then yes, that is the model. That is the way we construct our model. And the sensitivity are we calibrated against travel diary data. So then we have a distributed value of time in the simulated synthetic population. And then we also consider some other parameters in building a model, including socio-demographic and like lagged variables on what people are using currently. And those parameters are taken from existing SP studies. Yeah.
All right. Okay. All right. That's really great. That's good to know that at least like there were some form of trade-off calculation, whether it's coming from existing studies or not. And another finding that was very interesting to see that, there are already the system which is not already existing, we still can see that there are equity issues right? Because it's likely to be again a mode for those people who already can afford other alternatives. In that case, I'm just like, you are developing the model, yes, but just for, you know, for future thought, what do you think about differential subsidy for those people who are on, you know, in the socio-demographic class where they have lower income? What do you think is, will there be any consideration once you're going to have UAM in operations, that kind of consideration? Or we will just exactly start as we have started the ride-hailing system or shared e-scooter system? What is your understanding?
Sure, that's a very good question. Of course, equity issue is a very serious issue we need to look at. And there are certain ways we can, with UAM, we can try to alleviate that. Some of them could be to look at the accessibility of UAM, to improve accessibility, especially in those areas that are underdeveloped. Another way could be to use UAM to complement, for example, public transit. So then, or there could be some ways that the regulators can do to support some of those low income to use UAM, for example. So there are ways that we can discuss to make this more actable. Yeah.
Yes, and in my opinion, all the time, you know, we always think about whether chicken first or egg first, you know, but I think given that we already have a lot of emerging transport system in our transport system, if we are welcoming another new system, we need to think about the regulations beforehand. It's very nice that you are already considering the balance between demand and supply for that. I think we have another, okay, it's a comment. So from Parady, totally agree with you, Yasmin, thank you, about equity. From a different angle though, as a hardcore pedestrian, I think regulation is a very big issue. In order to avoid the mess, we made of our cities with our roads, but in the air. Yes, I totally agree with you, because I think, you know, as again, we have to think about the equity, and we have to think about the equity distribution, both horizontal and vertical, before we welcome another new mobility system. Chen, do you want to add anything on top of that?
No, that's totally a very good comment. And I think the reason why we want to do this kind of study is also to understand what are the ways we can do. So for example, by seeing the difference in different scenarios, we can kind of see what kind of change we can make to supply such that the equity issue can be alleviated. Yeah.
Yes,
Thank you.
Great. Thank you very much. And Jinping has a comment. So as a co-author, I want to add, I think our next research direction is to study this from user operation and system perspectives entirely. And there should be some design studio-based study to understand the qualitative measure also, because this system is not in our transport network. I entirely agree with you. Thank you for your comment. So we will open up the floor for Q&A again once we are done with all the presentation. And now the next presenter is not present at this stage, so I will move forward to the next presentation, which is mine. I have shared my screen. Can you see that? Can everybody see my screen?
Yes, we can see it.
Okay, the presentation mode, right?
Yes.
Yes, perfect. Thank you very much. Hello, everyone. So I will introduce myself, and I'll time myself to see that I am finishing within 15 minutes. All right. Hello, everyone. Thank you very much for joining us this afternoon. And today I'll be talking about different aspects on what Ellie and Chen mentioned. I will talk about existing travel demand and existing travel behavior from passenger perspective. And I will talk about the effect of COVID-19 on travel behavior. Specifically, I will talk about how it influenced the travel decision mechanism at the household level. And I'd like to start by acknowledging the Karbal and Yugara as the First Nations owners of the lands where Queensland University of Technology now stands. We pay our respects to their elders' laws, customs, and creation spirits. We recognize that these lands have always been places of teaching and research and learning. I am Shamsun Nahar Yasmi. My colleagues and friends call me Shams. I'm a senior research fellow or senior lecturer working at CARSQ at Queensland University of Technology. I am an associate investigator of the Center for Behavioral Economics, Society and Technology at QUT. It is most popularly known as BEST Center. Also, I am serving as an adjunct faculty member at University of Central Florida. My research is focused on the application of econometric models at the user, system, and planning level to provide behavioral underpinning and holistic understanding from different aspects of transport science. And I have established and leading an interdisciplinary econometric modeling group at QUT. From this group, today I would like to acknowledge the contribution of my undergrad students, Ashley, James, and Mark, who are working on this topic for their undergrad thesis. And I would also like to acknowledge Dr. Ritika Fosen, who is a postdoctoral fellow. So without further ado, let us move on to the main presentation. We know that over the last decade, something of enormous is changing in our day-to-day life with the advent of advances in technology, computing, and communication. For example, in transport system, shared mobility system, it became a part of our modern society. Then as Chen mentioned, we are thinking about UAM in future. And over the last decade, other than the transport sector, we have also seen significant changes in the economic activities. We have gig economy, she economy, and all sorts of other jobs that are emerging. So these changes are causing significant disruptions in our transport system. In the midst of all of these changes, we had COVID-19 outbreak at the beginning of 2020. The pandemic has disrupted our ways of lives and the transport system. The lockdown and the working from home provision at the beginning, it actually reduced traffic load on the network. We have seen significant changes in travel behavior with both positive and negative outcomes. And from the travel behavior perspective, the focus has significantly shifted towards accommodating or maintaining physical distancing. In the long run, such space-conscious travel behavior may discourage people to use public transport and encourage increased personal car ownership or increased vehicle kilometer travel. In fact, after the post-pandemic period, when everything opened up, we are observing a realignment in the typical peak commuting hour rhythm, specifically in the South-East Queensland, where I live, with increased traffic stress from high car dependency. Therefore, the traffic management and the transport infrastructure investment decision taken in this short term after post-crisis, it need to be robust across the range of positive and negative impacts of COVID-19 crisis on transport network. So in developing such effective and robust travel demand management strategies, an important part is the understanding of travel choice made by households and individuals across different temporal and spatial dimensions. This understanding is important as it will impact the demand forecasting and eventually the policy formulation. Today, we are focusing on the short-term decision process, choice of travel modes, and number of trips made by different households in a typical day. We will try and understand what are the differences in this short-term travel decision mechanism in the COVID period relative to the pre-COVID period. And I'll be showing a case study from South-East Queensland region. The major focus of this study is to examine the effect of COVID-19 on travel behavior at the household level. So in this study, we have focused only on home-based trip, where the trip is originated from home. We did not consider other trips in this study. And we have examined household travel decision as a two-dimension of travel decision mechanism. The first one is total number of trips conducted by a household in a typical weekday. And the second dimension is the distribution of those trips by travel modes. And for this study, we used household travel survey data from South-East Queensland from 2019 to 2021. 2019 data for 11 months is considered as pre-COVID period, and 2020 and 2021 data for 11 months, again, considered as the as COVID period data. And this household survey data is collected from 8 local government areas within South-East Queensland. These are Brisbane, Gold Coast, Ipswich, Logan, Moreton Bay, Noosa, Redland, and Sunshine Coast regions. As I mentioned before, we have 2 dimensions of interest. The first dimension is total number of trips made at a household level in a typical day, which is a count variable. And the second dimension is number of trips by travel mode. The modeling of second dimension is challenging since a household can choose to use multiple travel modes in a single day, which gives rise to multiple discreteness. The term multiple discreteness refers to a situation where the decision maker, in this case its household, have the option of choosing several alternatives from the universal choice set. So in our second dimension, in the problem set of our study, we have multiple discreteness where a household has chosen multiple trip mode options in a day. So somebody in a household, if there are 5 members, somebody can walk, somebody can take public transport, somebody can drive in a typical day. And for modeling such multiple choice set, traditionally we use multivariate modeling framework based on simulation-based approach or based on analytical-based approach, such as copy-based approach. And now, in this traditional multivariate modeling approach, impact of exogenous variables are quantified through separate functions or separate equations. Let me give an example. Let's say that in a multivariate setting, we have 4 different dependent variables. So if we want to examine the effect of an exogenous variables, it goes separately into all of these equations, and we estimate separate effects of the same variable across different equations. So there is no interactions of observed effects across multiple dependent variables, and the main interactions across different dimensions are sought through unobserved effects. But remember that this is not a limitation, of course, because this system gives us with more information than univariate modeling system. But it might be interesting to examine the effect of exogenous variables in a single framework that directly relates a single exogenous variable to all dependent variables simultaneously. But in traditional univariate and multivariate modeling system, we cannot do that. An alternate approach for examining such joint process is the application of fractional split approach. And in fractional split approach, we convert the multivariate problem set to an univariate problem set by converting our multivariate variable as fraction. So let's say that in a household, there are 10 trips. 5 were made by car, 3 were made by public transport, and 2 were made by walking and biking. In that case, our fraction would be 5 by 10, 3 by 10, and 2 by 10. So this is how we form the dependent variable for our fractional split model. And in this system, exogenous variable affect proportion through a single equation. But in the multivariate system, we had multiple equations. So as you can see, this system, it's parsimonious and computationally less burdensome relative to the traditional multivariate modeling system. And in this specific study, as we had 2 dimensions, the first dimension is trip count. We modeled that by using negative binomial regression approach. And the second dimension, which is number of trips by trip mode, and we converted that to fraction. And we modeled that by using multinomial fractional split approach. Both of these dimensions are modeled simultaneously. And we have examined the contribution of different factors separately for pre-COVID period and COVID period. I will not talk about the mathematical formulation in detail. I have just presented the log link function from negative binomial model and the utility function from multinomial fractional split approach. In these 2 equations, the psi term, the one that I have highlighted in red, this is the unobserved factor that are stitching together these 2 different equations simultaneously. So finally, to model this joint system, we apply quasi-Monte Carlo simulation technique. In this slide, I have presented the trip count distribution for these 2 wave pre-COVID and COVID period. So as we can see that trip frequency is lower at the household level during the COVID period relative to the pre-COVID period. And in this slide, we have our fraction variable, which is number of trips by trip mode. And from this slide, we can see that passenger trip share has actually increased during the COVID period, and public transport share has decreased. in most of the cities and the countries that has happened during the COVID period, but walk and bike share trip has increased. So which is good in the sense. And in developing the model, we have complemented household travel survey data with different land use, socio-demographic, and accessibility measure information. I will briefly talk about the model results for the COVID period only. And so this slide presents the summary of the results for the negative binomial component, which is the trip count component. In general, we can see that households with higher vehicle ownership is likely to make more trips. And travel time TT to POI, it represents travel time to different service locations, such as bank, post office, shopping mall, or GPs. We can see that if the travel time for a household to these service locations are higher, they are likely to make more trips. And also the households which are located in Brisbane local government area, they are likely to make more trips relative to other local government area. The joint system, the fractional split approach result is presented here. And in the COVID period, we had information about working from home. As you can see that working from home has positive effect on passenger mode share and also on walk and bike share, but it has negative impact on public transport share. And compare a travel demand mechanism between the pre-COVID period and the COVID period. Once we have estimated the model, we compare them by calculating elasticities. So elasticity, it's an aggregate level measure where we can compute the percentage change in our dependent variable due to the change in an exogenous variable while keeping everything else the same. And so it's going to be very time consuming if I talk about all the elasticity measures. That's why I have presented elasticity values from some of the selected variables. So in this slide, we have the elasticity values for expected trip counts, and we can see that households with more cars and part-time workers have higher contribution in making more trips during the COVID period relative to the pre-COVID period. And households with more retirees, the trip counts for them has decreased by 3% during COVID period relative to pre-COVID period. Now, let's talk about different mode share. So here we have the elasticity values for drive mode. And from here, we can see that the contribution to drive mode has slightly increased in households with more part-time workers in COVID period, but has decreased in households with more retirees. It is also interesting to observe that travel time to service location had negative impact on drive share in pre-COVID period, but the effect is now positive in the COVID period. For the passenger trip share, the results are along the line where we can see that the effects are different between COVID period and pre-COVID period, pretty much. And with regards to public transport mode, we can see that there are significant difference in the variable effects between COVID period and the pre-COVID period. But surprisingly, the contribution of vehicle ownership has actually increased on public transport mode share during the COVID period relative to pre-COVID period. And with regards to walk and bike, there are significant differences across different variables, but we can see that travel time to different service location did not change with regards to walk and bike share. But travel time to miscellaneous shopping center have actually decreased, the contribution to walk share has decreased during the COVID period. And for the shared mode system, I would just highlight one of the results. As you can see that the shared mode contribution has increased by 100% during COVID period with regards to the travel time to different service locations. So people have used shared mobility service to get to different service locations during the COVID period. And finally, one of the slides that I will quickly touch base on is the effect of working from home on the mode share. And as I mentioned, we had this information only for COVID period. And as you can see that working from home has positive impact towards walk share and passenger mode share, but it has negative impact on driving, public transport, shared mode, and other mode alternative. And at this stage, we are also looking into other dimensions of travel demand dimensions. For example, we are looking into trip purposes and trip distances. And the outcome of these studies can be used to identify effective travel demand management strategies proactively, so that we don't, we can take into account the negative impacts of COVID-19 and have an efficient transport system. So that's pretty much the target, and this is the initial finding from one of the studies. Thank you very much, everyone, for your patience in hearing. So that would be my 20 minutes. Does anyone have any question? Let me see this. All right. So one question from Ili is interesting to know that there were differences in those areas, and if you focus any noticeable difference finding from ITLS survey. Hi Ili, would you mind to tell me which one is ITLS survey?
Oh yeah, so the survey at University of Sydney did it in three
waves. Okay.
Three ways, yeah.
Yes. No, I didn't have that data, by the way, but I have seen the report when I think Professor David Hensher was leading that project and looked into the effect of working from home. Yes, but no, I haven't seen that data though.
So,
but the results are
finding,
comparable.
Yeah, sorry, what was it?
Some of the effects of the variables are comparable.
Oh, yeah, okay.
Yes, yes.
So also, Shams, I have another question. From the elasticities, do you think can we infer if they also come back to normal faster, or was it the?
Yes. So what would be, you know, what we have seen here in Brisbane, just in the Brisbane city, is that public transport demand has kind of picked up already by this time. But surprisingly, that demand in some locations where we already had all the captive riders, in those locations, the demand came back to normal. But in other locations, we don't have that much demand anymore. And we don't yet have the information about residential relocation, but we actually have observed a significant relocation from city center to suburb. And those trips, which were perhaps made by walk, bike, and public transport, eventually are now is making by, you know, drive mode. So that's something we are expecting to look into, those kind of effects when we are going to have 2022 wave data. But in my understanding, we actually have the negative impacts retained in the transport network of the COVID. But the positive effect in terms of, you know, walking and biking, the uptake of walking and biking, we are not seeing that positive impact to retain. But yes, in some locations, we have that positive impact. So we are waiting for 2022 data to prove all of these hypotheses.
Oh, great. So you're also again collecting another round.
Yes, another round, because we need to understand whether we went back to normal or actually we kept something in our transport network.
Okay, yes. Very looking forward to that.
Thank you. So what are the policy implications? Jenna has asked. So the policy implications would be to see whether we are, because before COVID-19, even then, the transport externalities that we have in our transport network were traffic crash, air pollution, and then emission. And during 2022 and 2021, we have seen that no, those became quite manageable other than road crashes, because we had few severe road crashes. So at this stage, when we are looking into this kind of models, we are trying to understand whether we need to rethink our policies or travel demand management strategies that we had to reduce crashes, to reduce air pollution, and to reduce traffic congestion. Because it seems like that people are getting back to their car no matter what, even the number of driving trip that has increased in 2021, also at the end of 2021. So it's very important for us to look into these dimensions and then try and understand how we can manage this increased induced car-centric demand again. Does it answer your question? All right, that's. We have another question. How can this model be transferred to other unanticipated events to manage travel demand proactively? This study is specific to COVID, but I imagine we don't want to experience similar event in the near future. What are those kinds of events that will be useful? That's a very good question. Yes, there are implications of this kind of model for future if there is any other uncertainty that we do observe in future. The first of all, yes, of course, we don't want to see another COVID effect or another kind of this kind of humanitarian crisis ever in our lifetime or even in future. One of the major, that finding, I didn't get the chance to present it. We are developing uncertainty of estimates. So that uncertainty gives us an idea how the estimates can change over the time if we have any uncertainty. So that uncertainty can inform us about the robustness of our travel demand management strategies that is existing. That's one implication. And another implication is this kind of event can result in uncertainty. So how we can take that into account, those kind of uncertainty in our travel demand management strategies, we can develop scenarios. 10 scenarios, 15 different scenarios by changing different dimensions and then see how that is going to affect our travel demand management strategies. So that's something we're also doing. We're developing scenarios by taking into account possible scenario, plausible scenario, probable scenario, and preferable scenario. So if we do that, we can actually develop proactive travel demand management strategies and also can validate or evaluate the existing travel management strategies. Okay, so and the next question is, yes, we have 1 more minute. About elasticity, I thought it meant when things exchanges, how it would be for Y. How is your last slide elasticity? Okay, so the last slide was for working from home. For working, to calculate the elasticity for working from home, we have considered that in a household, at least 1 person will work from home if that person is full-time worker. And what would be the contribution of that increased working from home idea on the mode share? So we have calculated in the second dimension of the model, we had fractional split approach. So we have changed X, the independent variable is working from home. We have changed that variable by assuming this specific condition, and then we have predicted the share of mode by using the fractional split approach. And yes, that's the Y in the second dimension. That's how we have calculated elasticity. All right, sure. Thank you very much, everyone. We have, I still cannot see our another presenter on this online, but we have André. So André, would you please mind to share your screen?
Yes, of course.
So Dr. André is a mathematical engineer, and he has a PhD in engineering systems from University of Chile. And his main fields of research are public transport and transportation network, new transportation technologies. Today, he will be talking about unreliability in ride-sharing system. So it's the floor is yours. Please go ahead.
Okay, so first of all, thank you very much to all of you for attending the session and to you, Sam, for moderating. As you can see in the screen, I'm currently a postdoc in Delft in the Netherlands. So you might be thinking why I'm connecting to this Australian session, but that's because next year I'm going to join the University of Sydney. So I'm very happy as the explicit purpose of this conference to start bridging to the transportation research community in Australia. Okay, today I'm going to talk about a paper that we wrote with Javier Alonso-Mora. And the main message I want to tell you is, why do we claim that on-demand ride sharing or on-demand ride pooling or on-demand flexible systems are more unreliable than traditional transportation? So if you want to keep only one message from this presentation, the main idea is that when a system is at the same time shared and on demand, there are new sources of unreliability, and the main reason for that is because the trip now depends on your circumstantial travelers that can change from one occasion to the other. So, well, first I'm going to introduce the topic, then we are going to give the formal definitions. I'm going to show you the results of some simulations, and finally I'm going to explain you an interesting trade-off that emerges with other indices related with quality of service to finalize concluding the presentation. So, okay, on-demand ride sharing, if you don't know what I'm talking about, very simple idea, you can think about Uber Pool, although what I'm going to tell you today is also valid if you think about, for instance, BlaBlaCar, when one passenger, where the driver is also a passenger, is not a professional driver. It's also valid if the system is centrally controlled. So in general, the idea is a system that operates online, where the vehicle can be shared by different passengers at the same time. This can be regarded as a promising mobility system. On the one hand, the massiveness achieved by on-demand systems reveals that there is a lot of potential for great quality, but also when they are shared, it is possible to fight congestion. However, when trips are shared and on demand, things are more unpredictable. So let me illustrate this with a first example. So imagine that you are traveling in this pink car over here, and in the top row, you are about to arrive at your house. You are 5 minutes away, you're hungry, you are already thinking about that delicious sandwich you are going to prepare when you arrive, but in that very moment, a new request appears, who happens to go to a destination very close to you and whose origin is close to the current position of the vehicle. So for the vehicle or for the system, it seems very, very convenient to deviate and pick this other passenger up. So that's what the vehicle does. But now instead of 5 minutes for you, it's 12 minutes. So those unexpected 7 extra minutes can be very, very annoying. And what I want you to notice is that this situation is inherent to being at the same time shared and on demand. Because if the trip was not shared, then you would, of course, follow the shortest path with no deviations. And if the trip was not on demand, you would know everything in advance, so nothing would be unexpected. So to formalize this, we identify first two big categories of the new sources of unreliability in this type of systems. What we are going to talk about today is this first class, which is the unreliability induced by the operators. Basically, that the vehicle's itineraries and how they update in time depend on how the operators decide to assign them to users. That's why we say it's induced by the operators. There is another source of unreliability that deals with the other users. Sometimes users are late in the pickup point or request a vehicle but then cancel it, and all these sort of behaviors affect all their co-travelers. We're not going to talk about that today, but if you want to read about it, this is a reference where we analyze that issue as well. So let us go to the unreliability induced by the operators, and here we distinguish again two subcategories. So the first one is the one-time unreliability. The one-time unreliability basically refers to the difference between the actual execution of a trip and what you are told in the first place. So this is basically the illustrative example I showed you before. You request a vehicle, you are said that it's going to take you 20 minutes, but in the end it's not 20 minutes, it is 28 minutes, because in the during those 20 minutes, new requests appeared and the vehicle's itinerary was updated maybe more than once. We call it one-time unreliability because it deals with one-time trip, right? Not with different repetitions. So we define some formal measures, the delta waiting time, delta detour, and delta total delay as the changes or as the difference between the original prediction and what happens. And as we discussed before, this only happens in shared on-demand systems. And actually, a very extreme case is that it can even happen that you request a trip, you are accepted, you are given some predictions, but then you are rejected, right? 5 passengers, a group of 5 passengers appear near you, so the system says it is more convenient to transport these 5 persons instead of you, and now you are ready. So an example of the measures, let us focus on the brown passenger here, and assume that all the arcs are of unit 1. So at the beginning, this guy have waiting time of 2 and has no detour because it goes straight from origin to destination. But when the red passenger appears, the vehicle itinerary is updated. Now the waiting time is 3, and there is 1 unit of detour. So delta waiting is 1, delta detour is 1, and the delta delay, the extra delay compared to the previous situation, is 2. So that was the one-time unreliability. The second type of unreliability is the daily unreliability, which is actually more similar to the classical notion of unreliability. Probably some of you are familiar with unreliability in transportation systems. That basically it is typically understood that as when you repeat the same trip many different days, you don't receive the same outcome. So if you are traveling your own car, okay, traffic congestion can be a source of unreliability because it's not always the same. If you take public transport and the headway between consecutive buses is not constant, then the waiting time can be also unreliable. The main issue in on-demand ride sharing is that users can face a different route each time. So this can have a much larger impact on the quality of service. So again, this is an illustrative example. In a lucky day, you go straight from origin to destination. You traveled alone because there was nobody there to share with you. But the following day, it was much more unlucky, and you have to make 3 intermediate stops, either pickups or drop-offs. Doesn't matter, but above it was 15 minutes, and below it was, let's say, 25 minutes. So imagine that you want to use this system to go to work, and you need to be at your office at 8:30 every day. Well, when do you need to call the vehicle? 15 minutes before, 25 minutes before, 30 minutes before? You cannot tell, and of course, that's troublesome. So in order to study, because, okay, we have the formal definitions, but how significant are these problems? In order to study this, we ran some simulations. This was done with a real data set of taxi trips in Manhattan in New York, which is publicly available. This contains about 20,000 trips within 2 hours of simulation in order to decide how to group the users and how to assign them to vehicles. We use an adapted version of the assignment procedure by Alonso-Mora et al., which is one of the most famous algorithms for this. And we consider 5 different scenarios regarding fleets, namely number of vehicles and size of the vehicles. This is a heat map of the demand. The only thing that matters here is for you to notice is that in this sector, in the center of the network, it is the hot zone where most trips are being generated. So regarding one-time unreliability, what we find is that it is very, very significant. So more than 30% of the requests face at least 1 change. The average number of changes is not very large, but the maximum can be between 6 and 8, depending on the scenario. So that means that, I don't know, if you assume that this is happening using your mobile phone, you receive 6 times a notification that your traveling time is going to increase. So of course, that's unacceptable, and it's very, very unlikely. We also find that the larger the fleet, the system becomes more reliable, and the same happens with smaller vehicles. Both things make sense because basically you are sharing with less people. So if you share with fewer people, it is more similar to a private trip, and therefore all these sources soften. We also analyze the spatial distribution. The main thing here is that when your trip begins in the hot zone, then it is going to be more unreliable. And what about the daily unreliability? The main issue with the daily unreliability is that we do not have copies of the exact same trip in a real life data set. So it is not straightforward how to analyze it. What we did was to insert different copies of 4 artificial requests, 100 copies for each request, 10 copies in 10 different days, and then compare the outcome of these 4 requests. So in order to analyze this, we drew the box plot graphs of the waiting times and of the detours. And the most interesting conclusions is, okay, first of all, request number 1 is the one that faces the largest variation Of course, you don't remember what is request number 1, but the main feature is that it's the one departing from the high demand area. So again, departing from a high demand area implies more unreliability, but all requests face significant changes. And yeah, to finalize the presentation, there is one more topic that I would like to present to you, which is a trade. So maybe some of you are thinking, okay, Andres, this is all what you have said is true. The one type unreliability in particular occurs, but it occurs only because you allow it. Because you could forbid some changes to occur. You, for instance, could say, okay, if we promise Alice that she's going to be dropped off in 15 minutes from now, then her vehicle cannot be updated during the next 15 minutes. And only after those 15 minutes, you are going to update it. But if we do so, then for the passengers that appear after Alice, that vehicle is not going to be available. And therefore, those passengers are going to face a worse quality of service. So basically what we did here was to put more restrictions to the conditions on how the vehicles can get updated and see what happened. So the base scenario is no restrictions at all. Here we forbid to reject an accepted request. And here we also forbid the waiting times to increase. And what you can see is that the average user's costs that encompass waiting time, detour, and the probability of being rejected increase more and more and more. So unreliability diminishes, but we pay a cost for that we increase waiting times and detours, and in the fully controlled scenario, we increase the rejection rate a lot. So just to synthesize what I was telling you, yeah, the operation of on-demand ride sharing induces novel sources of unreliability compared to previous or more traditional transportation modes. One-time unreliability, which deals with the sudden changes while you are traveling. The daily unreliability, that is the different conditions every time you travel, where the main thing here is that the route itself can change. And the numerical simulations basically reveal that both types of unreliability can be very significant. So they call for methods to think how we can control. So thank you very much for your attention. This is the reference. This is a paper not so new, but because of COVID, we couldn't present it before. So I'm also very happy to present it today.
That's great. Thank you very much, Andre. Does anyone have any question for Andre? Please raise your hand and then speak out, because we have half an hour, and then we had another presenter, but she's not here now. Does anyone have any question? Yes, please go ahead, Jenna.
Oh, yes. So first I want to ask, is your ride sharing a single ride platform or the share ride, which means like the passenger can get like multiple, can be multiple passengers in the car? That's like first question about definition of ride sharing. Please go ahead.
It is shared ride. And actually, if it was not shared, then these sources of unreliability would not be there, because they occur precisely because you have to make some deviations to pick up and drop off the other co-travelers.
I mean, it still could be, because your traffic condition is there, so there can be congestion and there can be detour, so you can still have an unreliable issue, right? Okay, I see. So it's share ride, got it. One more question, it relates to, you are using artificial like requests, or like the how do I put it? In the simulator, you're generating artificial requests. If, let's say, I could support you with the data set in, let's say, Shenzhen, China, I can get the DD data set to actually see real people's requests and reliability. Would you be able to estimate the same model using the same data, like this real data set? And what would you think could change, or would it be a better or more realistic answer to your current research question? What's your thoughts?
Yeah, thank you very much. So first, a clarification for the other thing. You are completely right that there still could be unreliability if it was not shared, but the sources I was explaining would not be there. So what we wanted, and I didn't say it in the presentation, but the emphasis we wanted to do here is, okay, what is happening here that doesn't occur in other modes? Because of course, traffic congestion can always be present, but the fact that you have to deviate sometimes to serve other users, and you do not know that in advance, because in public transport you also serve other users, but the line is fixed and predefined. That's what's specific to these systems. And regarding the artificial requests, so two answers for that. The first thing, just to explain in more detail what we did. Actually, most of the simulations are based on a real data set from Manhattan. It is a data set of taxi trips, so it's not exactly on demand. I mean, it's not an online coordination, it's street hailing. The only thing that's artificial is when we studied the daily unreliability, because to study the daily unreliability, what you need to identify is some requests that are repeated exactly from the same origin to the same destination and more or less in the same time. So you can say, okay, it's the same period, so the global demand is similar. And finding that in a real data set might be possible, but it's not always there. But other than that, the 20,000 requests are real life. Nevertheless, I would say that it would be very interesting to do this with the data you were mentioning. First of all, because it's always interesting to have more than one scenario, but also because I would argue that there is some flaw when we use taxi data sets instead of e-hailing, basically because in e-hailing is always door to door, whereas for taxis, you typically walk towards a big street. So the first part is not door to door. I wouldn't expect that to have a massive impact on the unreliability part, but if I have to speculate, probably it would be even more unreliable when it is door to door, because you have to make longer deviations to pick up the people because they are not gathered in the large streets. So it would be absolutely interesting to analyze that for sure.
I see. So hopefully, I mean, we can talk more after this, but I would love
Yes,
to
course.
set up some type of a cooperation and maybe share the data set with you. Let's talk about it later. Thanks.
Okay, thank you.
Thank you. We have one question here from Mahmoud Misbah. How large is this unreliability compared to other reliabilities for a private car?
So we didn't make that comparison directly. What we did compare was to, okay, what's the expected, for instance, extra delay compared to the average delay of the system. And what we found is that those are very similar. So what I'm saying is that if the average delay, where delay is precisely defined as the difference between what you obtain in the system versus what you would have experienced traveling by yourself, or equivalently, delay is equal to waiting plus detour. What we found is that if the average delay of the system is more or less 5 minutes, then the average extra delay, if you face any delay, because not all the passengers are going to face it, is also more or less 5 minutes. So those are comparable. We didn't make a comparison with other sources of unreliability, particularly in the same network. That would have been an interesting question to address, but we didn't think about that. So maybe I can check that after the presentation, because it's for sure interesting to put this in a scale with other types of unreliability.
Yes, thank you. Does anyone have any other question for Andre? And Andre, I would like to welcome you to Australia whenever you're going to reach here. I think you're going to come in 2023, right? So we
Most
have,
likely.
yes, you will be based in Sydney. I'm sure you already know Elnaz. She is in Sydney. I'm in Queensland. So you already know two people.
Yes. I'm very happy. Thank you very much.
Yes. Can you go to the slide? Okay, we have one question for you though, from Jenna. Can you go to the slide that has your contact info? All right.
My contact info?
Yes.
I think I didn't have a slide with my contact info. That's not very smart of myself, but let me check if I put it in the. No, I don't have a slide with my contact info, but I can put it in the chat.
Okay, that would be great. And does anybody have any other question for other presenters? And Elnaz had to finish pretty soon because we were thinking to have all 5 presentations, but please ask her if you have any question. I would have one question for you, Elnaz. That is, you know, with the freight, I am on the demand side. I don't, of course, like I don't understand the supply side and then, you know, the blockchain part of it much. But in my understanding, the demand data, or given that we don't have any commodity flow survey data for freight in Australia, how we can solve that problem of data unavailability, even to understand, you know, how to cater that supply problem that we are going to have. It's not necessarily entirely relevant to your presentation, but still I'm thinking about, you know, freight flow.
No, that's a great question, Shams, because as a person who also did a PhD on this topic, I also struggled a lot in terms of the data availability on freight, particularly here in Australia. I reckon it's always, I mean, everywhere is the case, but in Australia it's even like worse. Because of the business sensitivity of the data that freight operators don't really like to share that data. And that's a struggle that even state road agencies and federal road agencies also face. It's not only researchers. They also don't know that how many vehicles actually operate on their roads. So it makes it very difficult for them in terms of planning, as you mentioned, for supply and for, you know, what will be the growth of the demand of freight, how many trucks will use this corridor and so on. So it actually poses lots of questions. One approach, at least my solution would be the reverse engineering. So we have something called origin destination OD matrix estimation, which is kind of a reverse step of the trip distribution, right? So we actually observe the traffic flow on some certain points on the network, and then based on the, for instance, travel time or distance on the network, then you can do some, actually the method is entropy maximization. So you can actually come up with the origin destination matrices, and then from there, then you can also predict the attraction and production. So it's basically the kind of reverse engineering. So that's one approach that I was thinking why we don't use it, why state road agencies, they can just observe the traffic, I mean, the freight flow, the number of trucks, for instance, or even the weight on some parts of the network with some sensors, for instance, weighing motion sensors, or like even detectors just to count trucks and their sizes. And even like there are some already like ANPR cameras on the network. You know, there are multiple stations, multiple sensors that it can be used. And then when we integrate all of these data together, then we can come up with some approximation. But again, it makes it very difficult because when we are talking about freight, it has multiple dimensions. It's not only number of trucks. The other interest variables for freight transportation is, for instance, the weight, the type of commodity, the seasonality variation. So with one you know, snapshot, even we cannot get a full picture, because the freight movement is not like every day commuting to work. It's not like a passenger. So it has variations across the week, across the month, across the year. And so it makes it, you know, more complex and complicated. The thing is like freight transport operators already have some telematics. So they have insight and they actually record this data for on their own system, but definitely they're not willing to share it with the road agencies. Some other mitigating strategies would be perhaps anonymizing this data and then I don't know, providing, for instance, some incentive for freight transporters to share. Like, for instance, if they share their telematic data, their anonymized telematic data, then they can get, I don't know, discount on registration or discount on some of the toll roads, you know, some kind of policies. So, yeah, these come to my mind.
Yes, yes.
Sorry for long answer.
Currently, from the demand perspective, I'm looking into the vehicle composition, right? So the vehicle composition, because it has implications about infrastructure and infrastructure investments, and we have a lot of changes that are happening or encouragement that are happening within Australia about electric vehicle. And freight is in the freight sector, there is also an understanding that, you know, the fleet is very old, specifically for heavy trucks, and changing that is going to take like years in Australia. But we need to understand, once we are going to have a certain level of penetration, what kind of infrastructure we are going to need. And that's where the flow is very important, because we have to think about infrastructure considering the flow, because it's not just flow within the city, it's interstate flow. It's there is that supply and chain. So it's very difficult. It's very difficult. We are doing something along that line for the department, DITRDC, but it's just a snapshot. It's nothing.
Yes, I think I remember that actually I had a chat with the director of your with Karsky. Yes, it's a challenge. I totally agree. And then the bitrate data and the Australian Bureau of Statistics data, if you look at the vehicle composition, they just report articulated trucks, and it's not at the like a state level or network level. I mean, they report at the state level, but not at much more details in terms of yeah. But then we also, you know, in terms of for instance, when we are talking about like freight vehicle composition, then it's a prime mover and it's a trailer, and trailer can be attached or can be to the prime mover, and one prime mover may have different trailers attaching to that and operating on the network on the same day. So it makes it very difficult for even like the department to record this, because the prime movers, they have different plate number, trailers have different plate number, and then yeah, so basically, particularly in Queensland, it's very difficult, or some of the other states. But for instance, in New South Wales, they have a very intensive network of turtles, which are kind of infrared technology. So they're kind of laser sensors, so that they are installed, mounted on a, for instance, 50 centimeters above the ground, and then they can actually, they constantly actually broadcast that laser point towards vehicles, and then with the obstruction of the tires, that they can come up with the number of axles, and from that, then they can infer the vehicle size. So for instance, in New South Wales, they have this very intensive data, but yeah, not in some of the other states.
Not, at least like New South Wales has something, you know? Yes. Does anybody have any other questions so far? No?
Oh, I have one.
Yes, sure.
So this is the question related to blockchain as well. I'm totally new to this, but then what's interests me is that I like the idea of decentralized, and that's like safer and much better, which I understand. But the issue is that in order to make something happen, there should be like a central, or some, like I study agent-based simulation, so the agents should have like a motivation to do that. It's easier for the banks to have like blockchains, because as an agent, the decision making, they have benefit cost they could do. But then for transportation system, for example, for freight transport, what's your understanding about how can we make it real? Because all these organizations, government, or contractors, shippers, carriers, receivers? Who is going to be the person that actually, or to make it really happen? Any thoughts on this?
Yeah, Jenna, that's a great question again. So that's a challenge. And for instance, right now we see that like Maersk shipping line, they have their own blockchain platform, TradeLens. And some of the other international companies, they have started even like their own blockchain with different architecture. Some of them are permissioned blockchain, some of them are public, some of them are totally private. And it is again another kind of interesting thing that if it will be like lots of, for instance, blockchains that they have to talk to each other. So it's perhaps we need something as like an internet of blockchain, or but there are some good things about blockchain, that there are lots of interoperability algorithms that are being introduced, and they keep actually popping up every day. So these interoperability algorithms enable different blockchains and different architectures to talk to each other. It's similar to like EDI, electronic data interchange, that is not specific to your own thing. So, but then, for instance, in Australia, to make it real, there is actually one national blockchain roadmap committee that I also was lucky to be involved in that committee in a supply chain working group. So it's actually kind of initiated by the government, by federal government, to come up with a roadmap so that it enables adopting blockchain. And the other thing, for instance, one of the pilots that I was also involved when I was doing my postdoc research was initiated by Port of Brisbane, but then it was called Trade Community System, and they brought the Trade Commission, Australian Trade Commission, as well as customs. So, you know, some of these, because if, for instance, it starts from like customs and at that high level of trade, then all of these contracts and all of these transactions, if it be implemented in that platform, then it encourages other actors like shipping line and container terminals and so on to also jump in and participate, because if there is no barrier for entry, there is no cost for entry, and if they see that they can also hold on to their own data and so on. But again, that's a challenging thing. So I expect that some of these big shipping lines, for instance, Maersk, will kind of dominate this space for a while, and then there might be some other platforms just burgeoning in the next few years, and hopefully at one day then it becomes like an internet that everyone can kind of plug it with their own protocol, and they can be able to talk to each other.
I see, that's very helpful, thank you. But I do want to mention, as a researcher, we need to be like really careful with like all these, because I remember the person actually invented the internet at MIT. He had a talk about it. He was talking about at the time when they were like doing research on this internet, they didn't know it's going to be huge like this today. If they were knew that's going to happen, they probably would have other like saving some space in the www. Or the way they deliver it may be much efficiency. I mean, I heard a talk about that over MIT at one day, but that remind me of that. So as a researcher, we probably should be really careful with all these. But thank you, that's really helpful.
Thanks, Jenna.
I don't see any other question in the chat box. So we just have 10 minutes. Does anybody want to ask anything else, or just like share any comment or thought, anything? All right. Andre, what are you planning to do when you're going to be here in Australia? Are you also going to work on the line what you have shared today?
The main topic for me at the beginning, at least, would be the design of public transport, including these on-demand systems. In my PhD was mostly about public transport, and my postdoc has been mostly about on-demand systems. So how to join the two things.
That's great. We'll be waiting for you to be here.
Thank you very much.
Well, yes, and you can always, like, I wouldn't be much helpful. I moved to Australia 3 years. Elnaz had been here for longer, and for last 2 years, I actually couldn't go anywhere, and so pretty much I'm still new. Okay, yes, but still, if you have any questions.
I have a question from the audience.
Yes, sure.
Yeah, so I wanted to ask, what do you think about the BTR? Do you think is it sustainable? Because, well, to be honest, when we started it was before COVID, and the first 2 years, yeah, the number of papers were not too many, but then people were more enthusiastic in terms of, you know, participating. And if they had accepted paper, then they show up in the presentation and so on. But then I realized, like, since last year, people start kind of dropping off. It could be because of Zoom fatigue. And do you think, would it be sustainable? Would it be really useful in terms of providing accessibility to researchers from low income countries, or do you think no, it's better if we just, or kind of squeeze it into just one day?
I think, well, I will share my point of view first. I think we should keep our mind open. I mean, there will be ups and downs, but in my opinion, at least, like, since last year, BTR became quite popular. And the drops can happen for many reasons. We can perhaps have a survey after the conference is done, and then ask people why actually they couldn't join. Somebody perhaps, like, you know, because of the time gap or something. There could be some different reasons, not necessarily that might not be relevant to, you know, willingness to join the conference. So it would be good to know that point of view. But I think still there are significant scope, and it's very hard for, as I say, just not just in developing countries, low income countries, and also for the researchers around the whole world to travel somewhere. It's time consuming, it's expensive, and it's a very good platform. We have to just keep our mind open and then see how things go. At least this year, I have seen, like, pretty much, you know, a little bit of good participation overall, right?
Yes.
Yeah, so I think I would still be positive.
Great, thank you. Thanks, James.
No, I want to add that this is my first time attending this. The reason I attended is one of my colleague, Ali, at MIT, he suggests us to submit a paper to this. So for me, this is a new thing. Usually I go to TRB, but not this. But I mean, as first time experience, I really like this because it's a small community. We can talk about things. It's not like TRB. TRB is one time zone dominated by US. This is more like everyone in different places. I mean, even though it's still kind of dominated by certain places, but I feel like this is more international. I really like this, actually. Yeah, but about that, I think in order to boost the participation, one is to be well announced. For example, we should announce it at TRB if that's a way to do it. And secondly, I think it depends on the person that's organizing this. For example, I'm in China right now, so does Sally. So that's why we're in this time zone, we're participating in it. I didn't know about it, so I didn't get to share with my students, my colleagues in China. That's why they're not here. That's one of the another reason of that. If I were able to do that, I'm on vacation right now. That's another reason I have time for this. But then still, I think with certain person in each country or each lead university organization, over time, we can get there. Yeah. And how do I join the effort? I have a question about that too.
Oh, Jenna, that is fantastic to hear, and I'm so glad that you joined, and really looking forward to seeing you and all of your students next year as well. And if we actually need lots of help, because as you know, it's a free conference, and as Shams also mentioned, the main reason is just providing accessible research to all researchers from everywhere, like Africa, Middle East, low-income countries, as well as also, you know, having good quality, high quality research from Australia, Europe, other ones as well. So just connecting everyone basically together without any barrier of cost or traveling or visa. Yeah, so definitely I put my email here, so I would appreciate anyone if you are interested to join the organizing committee, just drop me an email, or Cara as well, if you have Cara's email as well, both of us. So for instance, Giancarlos joined our team, and he will be one of the fixed organizer for next year.
Okay.
Thanks, Giancarlos.
So I would also like to say something. I'm also my first time. I was very pleased on the quality of the presentations. As transportation professionals, we always look at demand, and we like to have a lot of demand. One of the things that COVID has taught us is that demand is not the most important thing. For us, it's having the service running, and serving people that really need it. So this format is great. I like having presentations from both sides of the world. For me, the time was really convenient because I start at 8 a.m. and I am ending around 11 p.m., but I can see all presentations. So it's just a matter of probably of getting a little bit more publicity in many other forums. But I really like the presentations, and as I said, it's a very high quality, and for me, all topics are interesting. I'm going to see all the recordings after this, the ones that I couldn't see because they were at the same time. But thank you very much for organizing, and I'm more than willing to help. I've already volunteered for the next one, and also to pass the voice on more people attending if that is an issue.
Thank you, Javier.
That's great. Yes. So if we do summarize all of our understanding, everybody likes it. Just to attract more crowd, we need more visibility and the platform to share it so that people actually know there are 2 different time zones and people can join conveniently. So just like increasing the visibility and sharing that message, I think will encourage people to join more.
Yeah, one more comment is the big names, like the big professors that can draw the crowds too. One of the reasons that I saw John Walker, I saw Chen and other familiar top professors in the area. Yeah.
Yes. Even like from, I think Karishma Choudhury, Professor Karishma Choudhury also presented, Pratik Bansal. So I have already seen few names. In that case, you know, crowd attracts crowd. So hopefully next year it's going to be even bigger.
Sure. Thank you, guys.
Well, thank you very much, everyone, for joining and sharing your insightful thoughts about the conference and about the presentations. And from the website, if you are interested to, you know, to share any other questions or comments with the presenters, please write to them and then reach out to them as is convenient. And thank you very much, Elnaz, for inviting me. It was very fun. And hopefully we are going to catch up. Yes, we are going to catch up next year again, if not before that. All right. And Elnaz, you can take a little bit rest. All right.
Thank you. Thank you, guys. Yes, so if you are a night owl, please also consider joining the Western session starting at 1 a.m. in Sydney's time. But yes, you can convert it to your time. Thank you, guys.
Okay. Thank you. Thank you very much, everybody.
Thank you.
Enjoy.
Bye.
Thanks. Bye. Bye.
Thank you. Bye.